Good morning, everyone. Welcome to the session 1E of Python Programming Part 1, our very first proper Python training of the HSMA 6 program. Last week you had a chance to well, maybe cry, I suspect. Anybody sat through last week, I know you had a lot of issues. I'm enormously thankful to both Sammy, who has been absolutely amazing at trying to help you resolve those issues via some clinics and posting in the chat. I know Sammy was very busy in the chat last week. It's looking like more of you have managed to get things working now. I know some of you still got some problems. Don't panic if you have. There are plenty of backup options that Sammy will post in the chat as we go through today that will tide you over for the moment as well. I believe Sammy's also going to put on some additional clinics for those that still need them and missed out last week. But also to say thank you to all of you, because it was, as much as it was a kind of chaotic session, which we kind of expected a little bit, because it's, you know, the session was kind of designed to let any issues bubble to the surface, and that they did. But it was really nice to see so many of you in your peer support groups working together, sharing solutions, helping each other. That was amazing to see. So and that helped a lot. So thank you to all of you as well. So last week, obviously, we were mainly introducing the IDEs that we're using, primarily VS Code. We also talked a bit about Jupyter notebooks. We touched on Google Colab as well. And we spent the afternoon kind of talking about Python packages and environments, virtual environments, and all sort of fundamental things that you'll need to know as we go through. And in the course of that, you did interact with some Python code. You technically wrote some Python code. You were writing bits of Python, but we hadn't really taught you anything. So today is where the Python training starts in earnest, where we'll take you through primarily fairly basic Python syntax today. That doesn't necessarily mean easy, and particularly if you're new to this, there's going to be a lot of information to take in today. There'll be a lot of information to take in over the coming weeks. I'll say right now, because people often think that they have to get to the end of these 3 Python sessions, and they will then need to be an expert in Python to continue, or they need to understand everything that's been taught up to that point, and that's not the case. There's going to be a lot of stuff chucked at you over the next few weeks, and if you're new to coding, if you're new to Python, some of this will take a bit of time to settle in. And the way it'll settle in is via you practicing it, and the rest of the course will see you practicing all of this stuff. So after Module 1's completed, after we've gone through the Python training, we'll then launch into Module 2, which is all about discrete event simulation. We'll be using a package called SymPy. There you will see some of the concepts we're talking about today. So you have a chance to practice all throughout the training. So please don't think that you have to get to the end of the next 3 weeks, and then if you don't know Python inside out, you're stuffed. That is not the case at all. The other important thing to flag up at this stage is that we are not teaching you all of Python. I'm not even sure that's possible, but we're certainly not teaching you all of Python in the next few weeks. What we're going to teach you are some of today, mainly some of the sort of the basic fundamental building blocks, things you need in most Python programs. Then over the next 2 weeks, we're going to be teaching you some things that are particularly important for scientific computing, which is the kind of thing that you'll be doing, modeling and data science. So we'll look at some packages like pandas and NumPy and things like that. So we're not trying to teach you everything, but we're trying to teach you enough that everything else will start to make sense. But as coders, as we said right at the start, you will be looking things up all of the time. We all continue to do that. There's no coder that memorizes absolutely everything. So this isn't to teach you all of the commands you need. It's to teach you, mainly to get a feel for how Python is structured and how things are coming together. Okay, so let's kick off by talking a little bit about Python now. So, Python, what is Python? Well, you remember back in the second week, in the Principles of Programming session, we talked about high-level and low-level programming languages. Low-level languages are those that are very close to the working of the machine, where you're almost talking directly to the components within your computer. Um, with a high-level programming language, things are strongly abstracted, so you can write in a much more natural language kind of way. The instructions are much easier to read and write, and then basically an interpreter will then interpret those instructions, and that will convert it into those low-level instructions telling the processor exactly what it needs to do and all that kind of stuff. So you don't need to worry about it. And Python is an example of one of those languages. Python's actually been around since the early 90s, which it seemed unusual to me when I looked this up, because you kind of think of Python as a much newer thing than that, but it's not. It has been around for a long time, but really the last 15 years is where it started its sort of meteoric rise, really. And it really has risen to prominence. It's now the most widely used programming language in the world, largely, I think, down to its scientific computing capabilities, which and its suitability for data science, which is why you're all here as well. Now, a really important feature of Python is its extensibility. And what that means, as we saw a little glimpse of that when we talked about packages last week, you can bring in code that other people have written to kind of extend that core Python functionality. And that's a really important feature of Python, and means you can do things like, I can teach you how to use neural networks. You don't need to understand the mathematics of neural networks so that you can code what a neural network is. Somebody's already done that for you. And that makes everything much more accessible. Python has also got a really neat feature where you can get very quick results, and you can build iteratively. So we talked a little bit about the interactive Python console last week, and you got a little chance to play around with that. That's basically where you can run a program and then say, okay, well, the program stopped running now, but it still remembered all my variables, and I can interact with it as though the program is still running via the console, and it allows you to test little things. It's really good for scientific computing purposes, and that's primarily the reason I used it for my PhD. Okay, so let's move on to our very first official piece of Python code. Now, it is a genuine tradition in the world of computer science that whenever you learn any new programming language, the very first program, the very first instruction that you should write is that prints the words "Hello World" to the screen. This is a tradition in computer science. It was very, very exciting when I did that back in 1985 on the TV set in the lounge, and got the words "Hello World" to appear on my television. Very exciting. I cannot emphasize enough how exciting it is to be able to control something that was a passive medium up to that point. I acknowledge getting the words "Hello World" up on the screen is perhaps less exciting these days, but nonetheless it is a tradition, and we shall follow that computer science tradition. So let us run a program that says "Hello World" in Python. So in Principles of Programming, we talked about functions and what functions were. We said that basically functions are enormously useful when we're programming. They are where we bundle up some code, some instructions that we're going to want to probably use multiple times, maybe even in different programs. It's a bundle of stuff that does something. And generally, when we write a function, it's good practice to have a function that does one thing well. So you don't want a function that does lots and lots of different things generally. You generally want a function that's very clear. The function does this, but it does it really well. Okay. And with a function, we can give them inputs. They don't all need inputs, and sometimes you'll get some outputs passed back to you in the code. And again, they don't all pass back outputs. So if we want to write some text to the screen, which we're going to need to do in our Python code to get the words "Hello World" up, then we can use something known as the print function, and it is just a function. And basically we use this syntax here, where we say the name of the function, and then we open and close brackets. And the thing that's in the brackets are any inputs that we need to pass. Now, in the case of the print function, that's basically whatever we want to write to the screen. Okay, the thing we want to print. You can have a print statement without. You can call the print function without anything in the brackets. That's fine. You have to have the brackets, but you can pass it with no input. And in that case, what it'll do, it'll just print a blank line. So it'll just go to the next line, and that can be quite useful when you're you want to put in a blank line in your output. So let's try this in VS Code. Let me switch over to VS Code now. So you'll need to go into, when you do this, go into File, New File, Python file. Make sure you're in your base environment when you go to run this. If for those of you that were playing around with environments last week, it won't matter for this. The des environment will work. It will also produce this, but there will be things in the following weeks that won't work in the des environment. So if I switch over to VS Code here, I'm going to type print to bring up the print function. Now I saw a few questions last week about I thought there shouldn't be a space. It doesn't matter. I tend to put a space personally, but you don't have to. It's entirely optional. I open and close my brackets, and now I'm going to pass in the input that I need. Now what I need to do is I need to use inverted commas in order to do that. Now I can use the double quotation marks, or I can use single quotation marks. It doesn't matter. Python accepts either, and that's basically our way of saying this is a string input. Remember, a string is just a sequence of characters. So that declares it as a string variable, and you're telling it, I want you to print to the screen this string. You can use either double or single quotation marks. You can't mix them in the same variable. So you have to, if you start with one, if you open with a double quotation mark, you have to close with a double quotation mark. You can't mix them up in the same in the same input. Okay, so I'm going to type hello world. I'm going to put an exclamation mark because I'm that excited. And there we go. That is my. Let me just zoom in a bit so make it a bit easier to see. That is my first program in Python. I'm going to type print hello world with the input in the brackets being the string I'm printing, and now I'm going to run it. And Zoom is going to get in the way. Oh, there we go. Sorry. Let's try it again. Run it in an interactive window. That'll allow it to pop up in the console here. And there we go. It's run the instruction print hello world, and what appears on my screen? Hello world. Very exciting, probably. Okay, that's your very first Python program. Right, let me. Yeah, I've already covered that. Okay, so that's how you print a message to the screen. Now, usually you'll use that kind of thing for in kind of real code where you want to display messages to the user as you're sort of going through, maybe updating what's happening, that kind of thing, or chucking out some outputs of your model or whatever it might be. Okay, so you'll use print all the time. It's quite a common function that you'll use. So let's now talk about variables. So we talked about variables in our Principles of Programming session. And we talked about variables as being essentially boxes. They're just boxes that have some information stuffed in them, and that box has a label on it, which gives the box its name, which gives us a clue as to the kind of information that's going to be stored in there. Now, we also mentioned that some programming languages are what's known as strongly typed, which means that you have to, when you create a new variable, you have to not only give it a name, but you also have to say what type it is, and say this is a string or this is an integer or whatever it may be. With Python, you don't need to do that. Python is not a strongly typed language. They are dynamic. Any variables that you create are dynamic, so it will automatically adjust to whatever you put in it. So if you give it a string value, it'll say, oh right, I'm a string now. And as we mentioned, that has advantages and disadvantages, but we'll focus on the advantages because we do like Python here. Now, the way we do that in Python, the way we assign a value to the name of a variable, is we use the assignment operator, and the assignment operator is the equal sign here. Now, what that's basically saying is let this have a value of this. That's what the assignment operator does. And it can be a bit confusing if you're new to coding because it's the equal sign, and equals does not mean equals in the way you think it does. Okay, so in Python, a single equals mark like that does not mean equals, it means assignment. So here we've got a variable called name, and it's being assigned the value of Dan. Okay, so it doesn't say is the name equal to Dan, it says let the variable name have the value Dan. Okay, let the variable age have the value 42. Let the variable is trainer have the value true. Okay, and some nice examples of different variable types here. So this would be a string, this would be an integer, and this would be a boolean. Remember, we talked about booleans as being really useful where they have a value of either true or false, and they're really useful in conditional logic in particular. So because Python is not strongly typed and instead variables are dynamic, when we create a variable and give it a value, if we then change the value and give it a value of a different type, that variable's type will change along with it. Okay, so let's imagine I create a variable called name and I first pass into it a string called Dan. Name is currently a string, but if I then say name equals 47, which remember is saying let the value 47 be the value for name, then it'll say, oh, Python say, okay, name is an integer now. And then if you change it to this 87.1, it'll say, well, no, I'm a float now. I'm a floating point number. And then you can change it back to another string and say, right, okay, I'm a string again. So it will change automatically depending on whatever you pass in. So you need to be aware of that because things might fall over if you try to do something with a value of a variable that will only work on a certain type. For example, if you wanted to add two numbers together, you can't do that with a string. So it's very important that you're very careful about how you set up your variables and assign them. So you've seen some examples of this already, but let's address this right early in our coding journeys. You've probably seen a lot of use of underscores in some of the things you saw just a moment ago, and also last week in particular. So the reason you're seeing that in a programming language, a space character indicates a separation between instructions, or between an instruction and its value. So if we want to write a name of something, like create the name of a variable, which we can name pretty much whatever we like, and very often that variable name will have more than one word because single words aren't often enough. We can't use spaces because the Python interpreter will see a space and think you're now talking about something else. Okay, so instead you have to adopt one of two conventions. The first is known as camel case, and camel case is where the first letter of the first word starts with a lowercase, and then you indicate each new word by using an uppercase letter at the start of that word. Okay, so that's camel case. And then there's a thing called snake case. Snake case, you basically just use an underscore where you would have put a space. Okay, now you can use whichever one you prefer. But you should be consistent in whatever you're doing. So whatever you do, don't write a computer program that has both. That's awful. It makes it very unreadable. Generally, though, for Python, snake case is the recommended approach to use. And in fact, it's PEP. I think PEP 8 recommends snake case. So you're free to use either, and I want you to use what you're comfortable with. But generally, certainly in this course, you'll be seeing snake case, and that's, I think, a much more readable one. I used to use camel case years ago, and I think is much more difficult to read personally. But yeah, the Python official recommendation is snake case. So wherever you've got a space, or you would have a space in the name of something, then just use an underscore instead. Okay, let's talk a little bit about variable types now. So back in the Principles of Programming session, we talked about how there were different types of variables, and we talked about what some of those types are. So let's see how we would write and use these different types of variables in Python. So probably one of the most common types of variable you use are the various number types. So we have things like integers, or int, as they're known in Python. Integers are just whole numbers, basically. Any number that doesn't have a decimal point is an integer, and is an example of an integer value, 42. And the other one that you'll commonly use are floating point numbers, which we call floats. And floating point numbers are any number with a decimal place up to 15 decimal places. Now, there are other numeric variable types that will deal with if you need precision beyond 15 decimal places. I would argue for the sort of thing you will be doing, you will never need that. In fact, if you are doing that, there's probably something wrong about the approach you're taking. Remember our talk when we talked about introducing modelling and data science, that we are essentially building models that are bundles of assumptions, and we're trying to simplify as much as possible. The last thing you want to do usually is go down to that level of precision for the kind of thing that you'll be doing. So I would wager that you would only ever, for your work, need integers and floats as your numeric types. Then we've got text. Now, we did mention in Principles of Programming that some programming languages have separate types in terms of text. They have things called strings, and they have things called characters. And so you have a character type, which is just a character, which might be a letter, number, symbol, whatever it is, and then a string, which is a collection of characters. In Python, it's simpler than that. You just have strings. There is no separate variable type for characters. You just have a string of length 1 if you've just got a single character in your string. Now, strings, commonly abbreviated to str, they are basically just sequences of characters. Now, they are, because they are sequences, they are known in Python, we'll come back to this, they are known as something called an iterable object, which sounds very fancy, but it basically just means something you can iterate over. And so a string in Python is a list. It's treated as a list, so you can refer to elements of a string in the same way you can when we come on to lists in a bit. In other words, you can say, what is the 4th character of my string? And that's really handy for some applications. And remember, we denote a string using either double quotation marks or single, but try to be consistent. Sometimes you'll see them mixed up in the same code when they're representing different things. I tend to do that a little bit. Some types of string I put in as a single quotation mark, but at least be consistent in terms of how you're applying it within your code. Then we've got the variables of truth, which are booleans, which are abbreviated to bool in Python. A boolean could take only one of 2 values, either true or false, and the T or the F are capitalized to indicate a true or false value. These are, and there's no quotation marks. If it was quotation marks, that would be a string. So it is the word true or the word false with a capital T or F as a Boolean value, and that will get recognized by Python as a Boolean value. Then we've got variables that can store multiple things, and you'll use these a lot, and we'll talk more about these a little bit later today as well. We've got lists. These are a very common one that you'll be using all the time. Lists are basically sequences of items where the order matters, okay? And you are allowed duplicates. You can have the same value as multiple entries in a list, and the order of the list matters. And that means you can refer to what is the 7th element of the list, what's the 2nd element of the list, etc. Okay, so the order matters in a list. And so here we can see an example of a list called myList, and it's being assigned these values. And a list in Python we denote using square brackets. Okay, So square brackets around the values in that list, and then the various values in the list are separated using commas. You can stuff anything into a list. So here I've got a list which contains an integer, a Boolean value, a string, a floating point value, and then another string value. Okay. You can even have objects, as which we'll get onto a little bit in a couple of weeks. You can have objects within lists as well, and a list is itself an object. So you can have one of your values in this can be itself a list which contains other values. So you can basically stuff anything into a list. We've also got these things called sets. So sets are like lists, but they are unordered. So the order doesn't matter. They're just a bundle of stuff. And they can only contain unique items. You can't have duplicate values in a set. You probably won't use sets as much as you will, or you definitely won't use sets as much as you will lists. You may not encounter them that much, but there are certain things that you have to use sets for, and you may see them for various things. We've also got tuples. Again, tuples are ordered like a... sorry, I should have said sets. We denote those using curly brackets. Okay. So tuples are basically like lists in that they are ordered, so the order matters. But unlike a list, they are what's known as immutable. That means that once you created a set and you've put in the values there, you can never change it. Okay, so yeah, unlike a list, which we'll see today, you can change the values within a list. You cannot change the contents of a tuple. Again, you probably won't use them that much, but they are used for certain things that you may encounter. So it's worth knowing they're there. And they use the standard parentheses, the standard brackets for tuples. And then the other ones worth flagging up are dictionaries. Now dictionaries, again, use these curly braces like sets, which can be a little bit confusing, but they are a bit different to the rest. So dictionaries, or dict, as they're commonly abbreviated, are unordered, so the order does not matter in a dictionary, and they are collections of key value pairs. Now we'll talk more about dictionaries later, but basically you have each value is essentially a pair. So you have a lookup value, which is your key, so the thing you'll use to look something up, and then the value that's associated with that key, and they are separated by a colon. So you can have things like, that your lookup key is tutor, and if I look up tutor, the value is Dan. If I look up number of modules, my value is 7. You see that they might be quite useful already, I suspect. So of these, lists and dictionaries are undoubtedly the ones you will work with the most. They are by far the ones that are most common of these four for the kind of stuff you'll be doing. And we'll be covering both lists and dictionaries today. Okay, let's talk a little bit about something, a really neat feature actually in Python called an fString. Now, these are, I say relatively new, they've been around for a few years now, but older versions of Python don't have this. All of the versions of Python you have will, unless you've somehow in sort of very old version of Python. But an fString, you saw a little example of that in the one of the exercises last week. They are strings, just like a normal string, but we can include some formatting within that string to define where we want to place some dynamic text, and it allows us to do things like insert the name or insert the value from a variable. So we may have, for example, a print message in our code that says her name is. Now, if it's the user's name, for example, we don't know what the user's name is until we ask for it. So we can't hard code. We can't say what the name is in our print statement. We have to draw that in from whatever the user puts in and stores into a variable. So instead, we can use an fString to say, I want you to print this message, but this bit of the message, I want you to use the value in this variable. Okay. And fStrings are really easy to use in Python. We simply put an f, a lowercase f, just before, with no space, immediately before our either double or single quotation marks that are about to indicate our string. And then we write our string as normal, but anywhere where we want to kind of get Python to step out and grab a value from somewhere else, we use curly brackets, and we type in, for example, here, the name of the variable that we want. So if we've got a variable called name of user, it has a value, string value here called Dan. I can then print a message using an fString that says hello, and then rather than hard coding Dan or any other name, I can use this fString formatting to say whatever is stored in name of user. So in this case, that will say hello Dan. And you can see I've put an exclamation mark after the closing the brackets. So you can put in more than one of these. You can, and within an fString, you can put formatting all around them and all sorts. And in fact, there's lots of stuff that you can do with an fString, not just that. You can do things like, basically, within your curly brackets, you can put anything that will, any Python instruction that will result in an output that can be translated as a string. Okay, so for example, rather than putting the name of a variable, I could put 2 plus 2 within my curly brackets. Now, Python will interpret that as an integer 2. I need to add that to another integer 2. It'll give it an output of the integer 4. An integer value of 4 can be interpreted as a string. It'll give it the character, the number 4. Okay, so that works. So you can put in little instructions like that. In fact, that kind of mathematical operation can be quite useful to do in an fString. You can also do neat little stuff like this. So sometimes we've got a floating point number, and we want to keep that level of precision because we want to use that perhaps in our in another calculation. So we don't want to round it while we're calculating, but we don't want to give all of those decimal points to the user. It's meaningless. So instead, what we can do, we can use rounding within an fString. So we can say, here's an example where we've got my float, which is a floating point number. Obviously a very famous floating point number here. And I'm using an fString with a print message here. So I use my little lowercase f, put in my message, my number rounded to 3 decimal places is, and then in my curly brackets, I'll put the name of my variable, just as I did before. But if I then add a colon, and then a full stop, and then 3 lowercase f, that says round this as a floating point number to 3 decimal places. Okay, so it won't change the variable value itself. The variable value will remain as 3.141592, etc. But the message will only display that value rounded to 3 decimal places, which can be really handy when you're communicating various results or outputs to a user. Similarly, if I put in 0.2f there, you'd get it to 2 decimal places. I could put 0.0f and it would round it to the nearest whole number. Okay, so it's a really handy little feature that you can use there, and that you probably will use quite a bit in your in your various travels. So I mentioned there about sometimes we want to get some input from a user, and sometimes we do need some form of input. Now, as we go through the various parts that we're covering in the course, you'll see that there are other ways in which, for the kind of work you'll be doing, that you'll be getting inputs from a user. And very often, in reality, the way you'll get inputs from models and things will be reading in a CSV file or something like that. But sometimes you do need to get the user to type something in. Okay, and when we want to do that, we can use an input statement in Python. It's actually really easy to do. So all we do is we call the input function the input to the input function. So just like the print statement had its input as being whatever we wanted to print to the screen, the input's input is also what do we want to print to the screen. This is the message that will be displayed to the user. But the difference here, by calling an input function, is it'll print that message and there'll be a blinking cursor then, well, in VS Code, it'll appear at the top of your screen in a box with this message, and then it'll give the user a chance to type something in, and it won't carry on until the user has indeed input something. And then, unlike a print function, which doesn't have an output, a print function displays some words on a screen, but it doesn't pass anything back to the code, which is what an output, a function's output is. An input function does have an output, and the output, as you may have guessed, is the thing that it passes back is whatever the user input. Okay, so if we call an input function and say, how old are you? Once the user types that in, the input function then needs to give us its output, whatever the user typed in. Okay, and this is an example of calling a function that has an output. We need to capture it in some way. We need to catch that. It has to put it somewhere. It wants to give it to us. And so what we do is we use, we typically store that as a variable value. Okay, so what this is saying is it uses the assignment operator just as you've seen before. Whereas before we'd have had something like age equals and then 42 or whatever the number we hard coded was. Here we're saying the value I want to give age is the output from this function. So Python will call this function, the input function. It'll print the words "how old are you" on the screen. It'll ask the user to type in something, and then whatever the user types in and then hits enter, that then gets passed back, and that will be stored as the value in age. Okay. Now, it's really important, particularly for this is a really nice example of why it's so important. Regardless of what the user types in, it will always, with an input statement, be read back as a string. Okay, so even if they type 42 with the numbers 4 and 2, that will be read back. Age will now store a string that has the characters 4 and 2 next to each other. It won't be read as the number 42. It's reading it, whatever a user input is, it's a string of characters. Now, that can be problematic, obviously, if we're asking for something like an age, because we're presumably going to want to do something with it, and we may need to do like mathematical operations on it, in which case that's going to be no good. We can't do that with a string variable type. So what can we do about that? Well, the good news is that as coders, we are all inherently wizards, so we can do something known as casting. And basically, casting is where we turn one type of variable into another. It's a bit like casting a spell. Okay, so we turn one variable type into another variable type. And we can do this as long as whatever we are trying to turn that variable into will work as that variable type and can be interpreted in that way, then it'll work. The spell will work. If it doesn't, we'll get an error. Okay, if you try to turn something that can't be interpreted in that way. So if the user were to type in Dan and we try to turn that into an integer, that's going to fall over in an error because Python can't turn the letters DAN into an integer. It can't do that. But it can turn the symbols 4, or the characters 4 and 2 next to each other into the number 42. Okay, so it can do that. Now to cast a variable into a different type, really easy. All we do is we give the name of the type of variable we want to turn it into, then open our brackets and put in the name of the variable that we are trying to perform the spell on. So here, where we said age equals input how old are you, here, that, as we saw before, that will the user will then input something that will be read back as a string. We can then, in our next line of code, say int, if you want to convert that into an integer, open brackets, and then pass in the variable value age, and it will turn age into an integer. So it will move away from being a string into an integer. And you can actually do all of that in one line of code, which is realistically how you'll tend to do it for something like this. We can wrap our input statement, we can wrap an integer cast around that input statement. And Python will read from the inside out. So it'll say, okay, I need to call the input function to get an input from the user. That will pass back an output. Remember, that's the whatever the user's typed in. That output will then be used as the input to this function, the integer function, which will cast it as an integer. So then the characters 4 and 2 will then be passed in and cast as an integer, and then that value will now be stored in age. Okay, so you'll get used to doing this kind of thing, and usually for casting you probably do it in one line of code, but you can do it in 2 if you prefer. But remember, it will only work if you can cast it into that format. So it's only going to work if it sees something that you can interpret as an integer in this case. Now, important little note, there's some little wrinkles here. If the user were to input a floating point value, i.e. they were to be very precise about their age and say, well, I'm 42.6547, you can cast that as an integer. Okay, so it'll be read in as the string 42.6547. You can cast that in this way as an integer, but it won't round. It'll just create an int value of 42, and it'll ignore all the decimal places. So be aware of that. Although, probably if you've written this, you wouldn't expect somebody to put in a decimal place, but there may be other applications where you do. But it won't work for strings, so you can't cast. Sorry, yes, I've confused myself there. If you have a float value, ignore this input. If you have a floating point value of 42.6547, you can turn that into an integer. You can cast it as an integer, and it'll give you the value 42, and it'll ignore the rounding. But it won't work if you were to use it for something like this, for an input, and the user were to input 42.6547, because that will then be, as an input, it'll be adopted as a string. So a string will then be stored that has the characters 42 full stop 6547. You can't then cast that as an integer. It will fall over. And you can see how confusing that is, because I just confused myself by doing that. And I found this out by accident by doing something else later in the training. So I thought it was worth flagging up. You probably won't encounter it, but just in case, particularly if you're either getting an input from the user or reading something in from a file, and it's a string that is representative of a floating point number, you cannot cast that as an integer. It won't work. You'd have to cast it as a floating point number, which is probably what you want to do, but just be aware there is that little quirk. So we keep talking about numbers as our variable types are being hugely useful, and for scientific computing that's likely the case. If we're dealing with numeric values, then we probably want to manipulate them in some way, and in Python we can apply various mathematical operations to variable values using a mixture of symbols that will probably make sense to you and symbols that may not make sense to you if you're not if you're particularly new to coding. So just to rattle through these, this one's fairly straightforward. A plus sign B means add A to B. That's fairly straightforward. Similarly with minus, that's fairly straightforward. This can be a bit more unusual if you're not used to coding. So this says A multiplied by B. We use the asterisk here. It is not A x B. That won't work. X is a character, and it will be looking for something called X if you put in an X there. Similarly, division, we use / here, say A divided by B. Modulus, we use the percentage sign here. We'll come back to modulus in a second. Modulus, or the modulo operator, basically says return the remainder from, so A divided by B and then return the remainder. And I'll come back to that in a second because it's quite useful. If we want to say A to the power of B, we use a double asterisk. So rather than a single one for multiplication, we use a double one to say raise A to the power of B. These ones down here are really useful as well. Little shorthand things when we want to increment or decrement stuff. And very often in your code, you'll be counting things or counting down from things. And this can be a really useful thing. So we could type. So, for example, imagine we had a variable called A, and each time through a loop or something, we wanted to add 1 to that counter. We could say A equals A plus 1. And that will say, let the value for A now be the value for A plus 1. Okay, so that adds 1 to A, basically. But a shorthand, a neat little shorthand you can do in Python, rather than say A equals A plus 1, because you do that kind of thing quite often, you can use this instead. You can say A plus equals 1, and that's basically just shorthand for A equals A plus 1. Because it's done so commonly, you can use this little shorthand notation. And that works with decrementing as well. So you can say A minus equals 2, or whatever the number is, and that's shorthand for A equals A minus 2. So you can put in whatever number you like here. 1 is the most common because you're usually using this thing for counting something, and you're usually incrementing, but you might decrement as well. So it's just worth flagging up. You'll see that quite a bit. Something plus equals typically 1, or it could be something else. Basically just means that value is that value plus 1. So I said I'd come back to modulus because that can be a bit weird, but it turns out it's really useful for certain stuff. So let's talk a little bit about it now. So modulus, as I say, you divide, you perform a division operation and then basically return the remainder. So if we had 10 modulus 3, that means 10 divided by 3 and return the remainder. So 3 goes into 10 3 times, but we would be left with a 1 as our remainder. So 3 times 3 is 9, so we're left 1 short, but we can't get any more 3s into 10. So we have a remainder left over, and our remainder is 1, and that's what would be the value returned from a modulus operation. Okay, so 10 modulus 3, the result would be 1. If we had here 20 modulus 2, that means 20 divided by 2, return the remainder. Now 2 goes into 20 exactly 10 times, and we've got no remainder, there's nothing left over. And so 20 modulus 2 would give us a value of 0. Okay, so it's a little bit weird if you're not used to that sort of thing. Modulus is really handy, and you hopefully see some examples of that today as well. Okay, so what I want you to do now is just do a very simple little exercise. I'm going to give you 10 minutes, so till past. Feel free to stretch your legs. We will have a formal break shortly. But you'll go into your groups. I just want you to write a really simple program using what you've learned so far that asks for the user's name, then it asks for their age, then it'll store the age as an appropriate variable type, and then it'll print a message that will say hello to them and how old they will be in 10 years' time. So it'll say, hello, Dan, in 10 years' time you will be 52. Okay. So I'll give you to 10:30 as I please help each other. So those of you who are newer to coding may need a little bit more help on this. But go in and into your VS Code. I think Sammy's going to post in the chat, if she hasn't already, an alternative if your VS Code is absolutely not working for whatever reason. Just to point out, you don't need, if you've got any problems with the environment stuff, this isn't going to affect anything with that. This is just simple Python. So even if you've got a weird issue with your Anaconda environments, you should still be able to run this in VS Code. Nominate one person to share their screen as well in each group, so if anybody gets stuck, they can talk them through it. Cool. Any questions about any of that? Great. Okay, I'll stop sharing and I will open up the breakout room. So see you at 10:30. Hi everyone, welcome back. So hopefully you all managed to do that. I'll just share my screen and show you the solution as well. And this, all the solutions from today, excuse me, will be shared after the session. They'll be uploaded. I'll do that tomorrow to GitHub. So there'll be solutions for all of the stuff that you're seeing today. So don't worry if you didn't manage quite to get there. Let me just share my screen. Okay. Oh, no, new VS Code. Right. Let me just, sorry. If I zoom in, I can't actually see the buttons. I have to keep moving this. What was it? This one, wasn't it? Yes, right. Okay. So, first of all, I've got an input statement here that I'm putting the message, what is your name, or something equivalent. And then the output of that will be whatever the user types in. And I'm going to store that as a name. Now that's a string, and I want that to remain as a string, so that's okay. I'm then going to ask for the age. So again, I use an input statement, but this time I'm going to cast it as an integer as well. You may have done that in 2 lines of code. One thing worth pointing out though, if you do it in 2 lines of code, you would have to do something like this: age equals int age to overwrite that value. Okay, so just be aware of that. Otherwise, you're not actually changing the value itself. You have to do that assignment operation. But if you've done it in 1 line of code here, then it should look something like this. And then I can use an fString to print out my message, which says hello name, whatever's the value in name. In 10 years' time, you will be, and then takes the age, and I'm doing the operation in the curly brackets here, age plus 10. So let's try it out. If I run that in interactive window at the top, it should pop up as in VS Code. This is where it'll appear. It can be different if you're using a different IDE. So what is your name? Dan. How old are you? 42. And it'll say, hello Dan, in 10 years' time you'll be 52. That's nice and depressing. Okay. And we got any questions? Sammy, is there anything that's come up in the chat about anything I've covered so far that's kind of urgent?
No, I think all good in the chat.
Awesome. Thank you. Okay, so I've got a little bit more to cover before we have a proper break, and you're going to do your first sort of real meaty exercise. And I will rattle through this fairly quickly because I can hear my cat outside the door demanding his treat. I thought I just gave him his late breakfast. He just rolled out of bed. I thought that might placate him, but clearly not. He recognises it's treat time. So let's go to this slide appropriately enough. Let's talk about comments. So comments are a hugely important thing when you're writing code that can often get overlooked, particularly if you're new to coding. So this is good practice to get into right from the off in your coding journeys. It is extremely important that whenever you're writing any code, that you leave comments that explain how various bits of code work. Now, it might be that you're explaining how a particular line of code works or a particular block of code, but you need some explanation in there. This is really important, not just if you gave your code to someone else so they can understand very clearly what each bit of your code is doing, but also, perhaps more importantly, to remind you what you've done. And believe me, you will forget why you've done certain things, particularly in larger, more complex pieces of code. So leaving comments, getting into the practice of putting comments around everything is really important. And there's basically 2 main ways of writing comments in Python. The first uses the hashtag symbol. So if you put a hashtag symbol in Python, that will indicate a single line comment. Okay, so you can then type everything. So you can then, whatever you type after that will not be interpreted as Python instructions. You can write whatever you like. It's just comments that the Python interpreter will ignore, and it's just for people looking at your code, including yourself. If you want to have comments using a hashtag over multiple lines, you'd need to put a hashtag on each line that you want to comment. So the second you push enter here, you're on a new line. If you want another line of comment, you'd have to include another hashtag. It's also saying that everything, as soon as you put in a hashtag, everything on that line of code from that point forward becomes a comment. That can be quite useful because what it allows you then to do, if you've got a very short line of code, you can put a hashtag on the same line of code after that piece of code. So you can do something like this, A plus B, and then put a hashtag after it and say this code adds the values of variables A and B together. Now, I don't tend to like doing this. You're usually better off putting it above the code. But you may see examples of this. And of course, you will probably run into the issue of the 80 character width, which you should, as we talked about last week, you should not be going over. So it's generally better practice to put them above, but you may see this and you can do this. The other way to do comments is you can use a triple double quotation mark character. So if you have double quotation marks, you have 3 in a row, that will open up a multi-line comment. Okay, so you can then start writing a comment, and it will continue to be a comment no matter how many lines it spans in your script, until the point at which you close the comment again by putting in another set of triple double quotation mark characters. Okay, that can be so these are really useful when you want to do a lengthier comment. It's also quite handy sometimes when you're testing your code. You just want to quickly switch off a piece of code because you're checking if something works. So you can use this to comment. It's what something is commenting out. So you can comment out your code to say, just turn it into a comment. That way Python won't interpret it as code for a moment. And this, if you want to do comment out a big block of your program, you can use this approach to do that. And it's quite handy for you don't want to delete it all. You just don't want it to run for a moment. You want to just check something else. So that's you'll also see it used quite often for that. Okay, so comments are important, and try and get in the habit right from the off. And I'm going to challenge you today for all your coding exercises. Try and make sure that you're writing clear and consistent comments in whatever you write. Let's talk a little bit about conditional logic now. So we first introduced conditional logic in the Principles of Programming session. And we said that conditional logic is really useful in our computer programs because very rarely are they perfectly linear. We usually want our programs to do different things depending on whether something is true or not. And that's basically known as conditional logic. And we gave this example here to say they're a bit like decision trees, that we say if this is true, then do this, otherwise do this. And in Python, we can apply conditional logic using if, elif, else statements. Okay, so let's have an example of how this works. So let's take the simplest example first, where we just have a single check that we want to do, and we say if it's true, then do this. If it's not true, then do this. Okay, so that's the simplest example of, well, actually, technically, the simplest example of conditional logic is where you just say, if it's true, do this. You don't have to have an else bit, but usually you would. So let's imagine we want to check someone's age and determine whether they should go to room A or B. And we're basically going to check, is the patient under 60? If they are, then we'll send them to room A. Otherwise, we'll send them to room B. Okay, this is how we would write that in Python. So we use the if statement here. Then we write whatever our comparison statement needs to be. So what this says is if the value stored in the variable age is less than 60. And then we use a colon. So Python will then check that. It'll check the value of age and see if it is less than 60 or not. If it is, then it will run this block of code here. Now, this could be however many lines of code you want it to be. In this case, we've just got a very simple example. We've just got a single line of code that just prints, please go to room A. But in reality, you'd probably do something a bit more interesting than that. But just for demonstration purposes, we've got something very simple. Now, you'll note the tab indentation here. And we talked a bit about tab indentations last week. Tab indentations are incredibly important in Python. Okay, those of you who remember the Pep 8 song from a few weeks ago will recall that it's one of the first lyrics in the Pep 8 song is about the fact you don't need no curly braces, just 4 spaces. That's what Python's all about. Okay, so some programming languages you'd put a curly bracket here and then you'd close it again at the end of the statement. That's not how Python works. It works on indentations. Now, if you're using something like VS Code or any other decent IDE, when you write this bit here and you type and you hit enter, it'll automatically tab indent you to the correct place. Okay, but if it doesn't, or if you've lost that in some way, you sometimes need to manually tab indent. So you just push tab, that's 1 tab's worth, it's 4 spaces. Okay. And basically what this says is Python will only run anything that is indented here within this block of code if this condition is true. If it's not true, we then run what is in the else block. So we can say else, and so it'll only run this line of code here if that condition is not true. So if the patient age is less than 60, then this will get run and this won't. But if it's not less than 60, then this will get run and this won't. Okay, so that's a basic format for an if statement structure in Python. You have the word if, whatever condition you want to check, then the colon, and then a block of code saying what to do if that's true. Now, you don't have to have anything else. You might just want to do something if that's true, and if not, you just don't do anything. But if you do want to do something if it's not true, that's different, then you would say use an else statement here. And you do the similar down here. You put in your whatever code you want to run if it's not true. Note that if you put in an else, you can't leave this blank. So if you want it to do nothing, then you have to leave the else out. That also includes a comment is not interpretable code. So you can't, some people do this when they're new to coding. They'll say, I'll just write my if statement. I'll write the else bit in a minute. I'll just put a comment in here. It will fall over. You'll get an unexpected EOF while parsing if you try to do that. Basically, it means that the Python's got to the end of the file and it thought there should be something else because it was expecting to be told what to do if that wasn't true. And it's basically saying if you just left a comment there, Python reads that as if the age is less than 60, then do this. Otherwise, and it just stops talking. So that's no good. So just be aware of that. Now you can also do multiple checks at the same time within an if statement. So it might be that we want to check the patient's age and we want 3 different scenarios. So it might be that if they're under 16, then we'll send them to children's. Otherwise, if they're between 16 and 59, then they'll go to room A. And if they're over 60, then they'll go to room B. And we can do that by using the elif statement. So we can enhance our if-else statement in Python by adding in an elif. So an else doesn't need a conditional statement because it just means if that isn't true, then do this. But an elif does. Elif stands for else if. So what this says is if the age is less than 16, then print please go to the children's room. If that's not true, then it'll go here and say, okay, well, if it's not true, if the age is less than 60, print please go to room A. Now, we don't need to check if they're also greater than 16 because we know that. If they were less than 16, this would never run because if they're less than 16, this block of code would have run and everything else would have been ignored. So we know if we've got to this point that the age is not less than 16, i.e. they are at least 16. So we can just say if they're less than 60, which emulates if they're 16 to 59. And in which case we go to room A. Here the else statement is basically saying if none of this is true, if you've got down here, none of that is true. So they are not less than 16, nor are they less than 60. So therefore they are at least 60. In fact, that should say 60 or over, not over 60. So that piece of code will only run if these 2 conditions are not true. And you can have as many elifs as you want. And else will only work if none of those elifs, none of the ifs or elifs are true. So keep talking about these comparison statements. We use these comparison operators to check what's called a relational statement. And a relational statement is basically any statement in Python that can be that will resolve to a Boolean value, one that is either true or false. Any statement that you put in an if statement has to be something that will either resolve to true or false. Okay, it's either true or it's not true. And these are the operators we use for this. So we talked earlier about how the equal sign does not mean is equals to in Python because it's the assignment operator. If we want to say is this value equal to this value, then instead we say equals equals. So we use 2 equal signs next to each other. That means is it equal to. So A equals B means value of A equal to value of B. So we can check whether that will either be true or false. Either A is equal to B or A is not equal to B. But you need to get in the habit of, if you're asking whether something is equal to, you need to use a double equal sign. The way I've always remembered it throughout all my life is to say is strictly equal to, and that those kind of two beats allow me to, my brain to put in the two equal signs, but use whatever works for your brains. So we may want to check as well whether something is not equal to something. Okay, and to say not equal to, we use the exclamation mark followed by an equals. That says value of A is not equal to B. Okay. We can then say value of A is greater than B. Value of A is less than B. If we use the greater than sign next to the an equals, that says value of A is greater than or equal to. So if you want to find out if somebody is at least 60, you could say greater than or equal to 60. If you want to check whether that's true. And you can do the same less than. You can say less than or equal to as well. We can also use these extra statements here, and an or, if we want to check multiple things at the same time. So the and statement allows us to check two different things, and if we put that in an if statement, that block of code will only run if both of those things are true. Or you could have three statements if all three of those statements are true. So this will only resolve to true if A is greater than B and A is also less than C. Okay, so both of those things must be true for this to resolve to a true Boolean value. You might have it though the other way around. You might want to say, I've got a couple things I want you to check. Only one of them needs to be true in order for this if statement to carry out this block of code. So you could say here, you could use the or statement. So this says, if A is greater than B or A is less than C, if one of those is true, at least one of them, then that will resolve to true. Okay. So let's cement that in our heads by playing a quick round of my new game show, comparison operator, true or false. I think this is going to be a huge success. So what I'm going to do now, I'm going to connect to Menti. I want you to do the same. So connect to menti.com. Oops. And I'm going to put up a code on the top of the screen, just as we had for the very first session. We're going to play here now, comparison operator, true or false. The Menti code is 63989414. I'm sure Sammy can pop that in the chat as well. Let me present this here. So you'll be presented with this. You've got 5 true or false questions that you need to answer. And basically, for each one of these statements, you have to say to which Boolean will each of these comparison operator statements resolve. Will it be true? If you think it's true, then I want you to put a tick. Or if it's false, which will be a cross. Okay. And here is your information, your variable values. Age equals 42, admissions equals 7, and distance equals 450. Okay. So based on that information, do you think these statements will resolve to true or false? So I'll just give you a couple minutes to do that. So true is a tick, cross is an X. If you forget the statement, you can hover over here and it'll reappear. So age is 42, admissions are 7, and distance is 450. We've got a bit of disagreement already. Once I turn this into an actual game show, there'll be some music at this point. We'll look at the prizes that you can win for correctly answering comparison operator true or false. It's going to be a real hit. Oh, got some disagreement on the first one now as well. Okay. So remember, tick is true and cross is false. Let's give you another 10 seconds or so. That fourth one in particular seems to have a bit of disagreement on it. Okay, let's have a look at what the correct answers are. Here we go. So the majority of you got the correct answers on all these, so well done. So first statement is saying, is age greater than 42? Well, the age is 42. So that is false. The age is not greater than 42. It is 42. So that would result in a false statement. This statement says admissions are strictly equal to 5. So admissions are 5. Well, what are admissions? They're 7. So that is not true either. That is also false. Then we've got this statement here, which says distance is less than 500 and the age is less than or equal to 42. Well, the distance is 450, so distance is less than 400, and age is 42, which means that is true. So age is less than or equal to 42. Well, it is. It's equal to it. So therefore, it is true in both of these statements. Therefore, this will resolve to true. The distance is less than 500 and the age is less than or equal to 42. The fourth statement here, which causes a little bit more of a disagreement. So this is saying the age is less than or equal to 40, or the admissions are greater than 5. Well, the age is not less than or equal to 40. The age is 42. So that is not true. But because this is an or statement, the other one can be true, and it'll resolve to true. And indeed, that's the case here. We've got admissions greater than 5. That's correct. Admissions are 7. So in this case, that would resolve to true, because one of those statements was true. And if there were 10 statements here with an or statement, then we could, as long as one of those things was true, the thing would resolve to true. Okay, so and or can be useful for your conditional logic to say, I need all of these things to be true, use and, or need just one of those things to be true, in which case use an or statement. And then finally, there's a little bit of a little bit more of a cruel one here, because I haven't strictly taught you this yet. I gave you Dan strictly equal to Dan. So this is mainly just to introduce you to a little wrinkle here. So we said that strings in Python are basically sequences of characters. That means that a string with a capital letter D at the start of Dan is not the same as a string with a lowercase letter d. Okay, so that would resolve to false. Those two things are not the same. That is a sequence of characters with a capital D, lowercase a, and a lowercase n. That's a string. There's a sequence of characters with a lowercase d, a lowercase a, and a lowercase n. Okay, they are not the same. And so that's worth being aware of right from the start, that that's how strings work. You'll encounter this problem when we come on to the natural language processing module, because you can imagine you then have to deal with things that might be capitalized, things that should be capitalized but weren't capitalized, and all sorts of things. And there's ways in which we deal with that in natural language processing. So we'll come back to that much later in the course. But just be aware of it for now, because it can catch you out, particularly if you're writing a program that asks the user to input something that might be like a name, and they might put a capital letter, and then if you're going to check that, you need to be aware it could be either. Okay, thank you for playing the pilot of my game show, Comparison Operator, True or False. I've no doubt that Sammy will write the new theme music with all her instruments by this time next week. We can all play another round of that crazy game show. Okay. So let's now go, well, we're going to take a break first of all in a second, and then you're going to work in your groups on the first proper exercise of the day. So far I've talked to you about print statements, I've talked to you about getting inputs from the user, we've talked about variables, we've talked about fStrings, casting variables, mathematical operators, comments, conditional logic, and comparison operators. And we've done all that in less than an hour and a half. Okay. So first of all, you're going to take a 10-minute break. Then in your groups, you're going to have 30 minutes to work through the Python notebook 1e_2 that comes in your repository. So if you downloaded for the materials from today from the GitHub repository, then open up Jupyter Notebook 1E underscore 2. Sammy will put in the Colab alternative if you can't use VS Code, but I think most of you can at least use it for this. If you open this in VS Code, it will open it as a Jupyter Notebook, as we looked at last week. And what I want you to do for each task, you need to read the instructions carefully, and then write your code, what your solution is to that problem, in the blank code cell underneath whatever the description is. The way I want you to do this, I want you to work, so you all need to do this individually, but I want you to be working as a group in doing it. So you should all be having a go on your own notebook, but I want one person in each group, you should nominate to share their screen, and I want you to help each other out, and I want you to make sure that you're all clear before you move on to the next task. So make sure everyone's following along for each task, okay? Particularly for task 2 of this particular exercise, I want you to work on this as a group and discuss how you're going to approach this particular problem. If you finish before the 30 minutes, before we come back, I want you to see what else you can write as a group using what you've learned so far. So if I just show you a moment, if I show you the Jupyter Notebook, being very careful not to show you the solution, which I also have open. So this is what it'll look like. You'll have this notebook. Let me just get rid of this. Sorry, zoom. I know you can't see this, but I've got a bar here, and it's really annoying because it keeps getting in the way. I'll move it down here a minute. Sorry, I have to keep moving it. I realise I'm not showing in video mode, so you have no idea what I'm talking about. But that thing that you saw in the first opening sessions, that keeps getting in my way now. Okay, so these are the instructions. You've got 2 tasks on this first exercise here. The first task in here, you've got to write some code that asks the user to input their monthly take-home housing cost, blah, 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 and it'll basically calculate their remaining amount. So read all that really carefully. This block of code, so this second block here, this empty one, is where you will write the solution to that task. This block of code I've given you here as a way in which you can separate out a print statement to stop you going over the 80 character line. Okay, so this is just an example of how you can do that for a print statement. So this will help you hopefully in your solution, which you'll put in here. And then the one you'll work on all together as a group, task 2, which is a little bit more complicated. So read this carefully. It'll ask the user to input a day from 1 up to 365. Assume that day 1 is a Monday, and whatever the day number the user puts in, it'll output what day it is. Okay, so a little bit more complicated. I have to say that does not require 365 lines of code. If you're writing that, you've taken the wrong approach. Okay, so any questions, Sammy, that have come up in the chat about any of what I've just covered?
No, I think that's good. There's a little bit of a good discussion going on about how to handle exclusive OR, but I think that people have come up with a few good ideas there.
Okay, no worries. You probably won't need it much for what you're doing, but that's good. That's really good to hear. Cool. Okay, so what I'll do, I'll stop recording now. I'll put you into your breakout rooms. It's 11 o'clock. Go and have, I'll open up the breakout rooms now, but go and have a 10-minute break first. So we'll resume at 11:40. So 10-minute stretch of your legs, and then go into your groups and have a go at these exercises. We'll resume at 11:40. Hi everyone. Welcome back. So I managed to get around most of the groups, not all, but really good. It looked like you were getting on really well and having a good go at this. Do make sure you're putting your cameras on. Somebody's got their camera on, even if you're working on things individually as well, because it helps us as well to we can go in and glance and see how well you're getting on. But it'll also help the other people in your group too. But some really nice approaches I saw to that, including a couple groups at least that were had either floated the idea, or the last group I was in that went through with the idea of using a dictionary, which I've only half taught you about dictionaries at the moment. You are going to learn the other bit that you'd need for this to work for a dictionary in a bit. But well done to those of you who did that. But the official solution only required things that that you've already learnt so far this morning. You'll see in the class tannoy I've posted the solution if you want to look at that. But they will all be uploaded to GitHub as well tomorrow, so you'll be able to get all the solutions there. But the solution, in case you want to access it for now, is available on the class tannoy. Okay, so well done. I think that was, considering your first proper code, I think that was a really good first attempt. So let's continue. We're a little bit overrunning, but we shall be able to make up the time, I think, this afternoon. So let's not worry too much about that. And instead, we will plough on. Right, where am I? Oh, I need to move my bar up here. No, that's way too far. Where are we? Loops, that's what we're talking about. Okay, so let's talk about loops now. So we talked about, in principles of programming, as well as conditional logic, we also talked about the idea of loops. We said that there are often situations in which you need to do the same thing multiple times, and it might be that you need to do the same thing a certain number of times, in which case we use a for loop, or you want to keep doing something whilst a particular condition is true, or indeed false. You could do it the other way around. And in which case you can use a while loop for that. So let's see how we would use these things in Python, because you're going to be using particularly for loops, but you'll use while loops a lot as well. But for loops you'll be using all of the time in your code. So let's take a very simple example here where let's say we want to count up to 10. Now, some of you noticed last week in the little exercises that Python, like many programming languages, begins counting from 0, okay, most of the time. Not for all, there are a few things where it starts counting from 1, but generally Python will start counting from 0, so you need to bear that in mind. So let's say we want it to count from 0 up to, but not including, 10, so in other words the number 0 to 9. Then we want to recreate this for loop, which basically says do this 10 times. So print a number, increment the number by 1, and then keep going back round until we've reached the value of 10. And this for loop will do exactly that. So this is the way in which we write a for loop in Python. We use the word for, and then we use this, which is referred to as the index for the for loop. Now I've used X here. You can use anything you like. You could use jam donut if you wanted to. It doesn't matter. It's the name, effectively, of a temporary variable that the for loop will use to indicate where it is at any point. Okay. Once that for loop is finished, that variable is disposed of. So you don't use it. It's only used for the for loop. Okay, so you can use it whatever you like. Generally, if you're using something like this where you're going counting up for a range, you generally use a single letter. X, I tends to be used quite a lot. It doesn't matter. You can use whatever you like. So here I'm saying for X in, and then range brackets 10. That says give me the range of numbers ranging from 0 up to, but not including, the value that I put in here, so 10. So this will give us the values 0 to 9. Okay, so range effectively gives you an iterable object. It's a list that gives you the numbers up to, but not including, whatever number you put in. Okay, so this tends to get used quite a lot for for loops. So if you want to do something 10 times, you can put in 10 here. You'd have to worry about the fact that it mostly that it starts from 0 for that. It'll just do this, whatever you tell it to, 10 times. We then use a colon, just as with an if statement, and then when we hit enter, we'll be indented, and that means everything that is then indented. We've only got one line of code here, but realistically for a for loop, you probably have multiple lines of code. Everything that is indented there will take place in the for loop. That means it will happen, in this case, 10 times. And the thing I want it to do in this case is to print this index. So it's just going to print the number that I'm counting up from. But it could be anything. It could be print hello Dan. It would say hello Dan 10 times. Okay. So if I were to run that code, this is the output I would get. It would first print the value 0. then it would increment automatically, because the for loop will automatically then go and increment to the next index value. So it'll become 1, then it'll print to the next value, which will be 2, etc. Up to, but not including 10. So it'll get to 9. When it then ticks over the index to the value 10, that's the point at which it stops. Okay, so you need to remember that the value you put in there, it will not include that value. So you'll get 10 iterations. Those 10 iterations will be from 0 to 9. And as I said, the code in the for loop can be anything we like. So in this for loop, this is saying for x in range 5, so do this stuff 5 times. That's this stuff, not this stuff here that's indented. Do this 5 times. And I want you to ask, get an input from the user, which can ask for their name. It'll store it in a variable called name, and then it'll print using an fString, hi, and then whatever name they've put in. So if you were to run that line, this code, it would ask for their name 5 times and print whatever they type in each time. Okay, so in this case, I've put in Dan. The next time through, I said Dan, etc., etc. Okay, so whatever, it'll ask for the user input 5 times, and it'll print the that message with that user input 5 times. And then down here, this is the line of code that is run after the for loop has completed. So you can see here, 5 times we got these hi messages, because it was going through this for loop 5 times. Then it got down here where it's printed the message, okay, I'll stop asking. Okay, so it'll go through the amount of times you told it to, then it'll move on. We can also set up a custom range. That can be important where, so if it's just the number of times, you want it to do something a number of times, then for x in range, and then however number of times you want it to do it, that will work fine. But sometimes the number, the index that the for loop is counting is important, and you want to use that in some way for your code. And you'll see lots of examples of that throughout the course. And so sometimes you want to set up a custom range. Maybe you don't want it to start from 0. Maybe you want it to start from 10. And you want it to count from 10 up to, but not including 20. Okay. So again, you'll get 10 numbers, but they will start from 10. It'll include 10, but it will not include the top number. So we can adapt the range by passing in 2 inputs. The first number is the number I want you to start from, and I want you to include that one. Then separate our inputs via a comma, and then the second input I'm putting in here is the value I want you to go up to but not include. So you need to remember that. So if you wanted 20 included, you'd have to put 21 here. If you don't want 20 included, you'd put 20. And here I'm just printing whatever the value of x is. So that'll count from 10 all the way up to 19. We can also customize the increment of the for loop as well. So let's say we wanted to go from 2 up to, but not including 30. But rather than count up in 1s, we wanted to count up in 2s. And we can do that. We can give it a third input. So these are known as arguments in a function. They're basically just the inputs that we pass to it. For a range, we have to give at least 1 input, which will be the maximum. If we give 2 inputs, it'll be from this to this, but not including it. And if we pass 3 inputs, it'll be from this to this, but not including it. And then the third argument, the third input, would be what's the increment. So but by default, that'll be 1. If you don't specify it, the default is 1. Just as if we only specify the maximum by just putting in 1 input, the default, it will start from 0. So this here says start counting from 2, go up to but don't include 30, and count up in 2s. And in my loop, I'm just going to print the value of x, and you'll see that's exactly what it does. It'll start at 2, 4, 6, 8, 10. It goes all the way up to 28. It'll then tick over to 30, but obviously then at that point it would stop. Okay. If you were to start that, say, from 1 and do an increment of 2, but with the same limit, then what would happen is it would go up to 29. It would then tick over to 31. It's exceeded the limit, it wouldn't include it. Okay, so you still wouldn't get 30. It would, if it's gone at least past the limit, then it stops. We can also do a decrement as well if we wanted to. It's exactly the same. We just put a minus number in front of the number by which you want to decrement each time. So in this case, this says start at 10, go down to but do not include 0, and the decrement is -1, so it'll count down from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, at which point it will stop, because the next time through it will get to 0. We can also, and this is probably more, so the increments and decrements and custom ranges you might use. You probably won't that much, to be honest. Most for loops are going to look like that. I want to do it this number of times, albeit probably with some more interesting code than just printing the number. Or like this. Because a for loop, I mentioned when we give it as a range, we say range 10. What that's actually doing is giving us an iterable object, a list, something you can iterate through. It's giving us the list of numbers from 0 up to but not including 10. We can actually explicitly specify a list of our own making as well. And that can be useful when we want to say, okay, I want you to go through each element of my list and do something with it. And so let's imagine we've got a list here, and we'll cover lists properly in a minute, that I've set up. Remember, we use square brackets for a list. My list is called my list, and it contains 5 elements, the numbers 1 and 10, the string Dan, the boolean true, and the string HSMA. And I can write a for loop that will go through each element of that list. And so here I can say, and to make it clear, I could use X again if I wanted to. Again, doesn't matter. But to make it clearer, I've decided to call it element. So I can make that clear. Okay, yeah, I'm going through each element in my list. So for element in my list, and all I'm going to get it to do here is nothing particularly interesting. I'm just going to get it to print out whatever that element is. And so it'll start with the first element of the list, which is the number 1. It'll print the number 1. Then it'll move to the next one, which is the number 10. It'll print 10, and so on until it gets to the end of the list. That's effectively exactly the same as what you're doing when you say for x in range 10. It's just you're using range 10 to shortcut, give me a list of numbers up to but not including 10. But you're doing the same, Python's doing the same thing behind the scenes. But this is particularly useful because if it's not about I want you to do this so many times, it's about I need you to do this stuff for each element in a list of stuff I've got. Then and you will use that quite a lot. Then you can use this kind of structure where you say for element in the name of your list, and then whatever you want to do to that. So those are for loops where we're doing something a certain number of times, whether it's a number of times we specify or if it's do it for each element in a list. We've also got while loops. And remember, while loops basically say keep doing this whilst this is true. So keep going around until this no longer becomes true. So here, I've got an example of a piece of code that says, sets up a variable, a Boolean variable called correct, and it assigns a value of false. So we use the capital F on false there. Python will interpret that as a Boolean now because it recognizes false and true as Boolean values. So it's said, okay, I've got a variable, I've got my box called correct, and in that I've put in a Boolean value of false. I'm now going to set up a while loop here that says, I want you to keep doing this whilst it's false. So I say while correct, so the name of the variable I've set up here is strictly equal to false. So equals equals, remember, means equals in the conventional sense, not assignment. So this means set false to the value as the value for the variable correct. This means correct is strictly equal to false. So whilst that's true, which is going to be at the start because we've just put false into correct, so it's going to run at least once. If I was to put while correct strictly equal to true, this would never run because it's not true, it's false. We've already set that up here. But whilst it's false, use my colon, again we get an indentation. So do all of this in the while loop and do all of this and keep doing all of this whilst correct is false. So the first thing it's going to do is it's going to get an input from the user saying to type yes if Dan is the best. If it then reads in that answer, and it needs to be all in block capitals because somebody needs to be very emphatic about it, then we've got an embedded if statement in here. So it'll run this piece of conditional logic. If the answer is yes, then it'll run this piece of code here. Well, it'll say, yep, that's the correct answer. And it'll then change correct to true. So what will happen then is if that was yes that was input by the user, the else bit won't run. It reaches the end of the while loop. It now goes to loop back round, but now correct has been changed to true, so it won't run again. If, however, the user inputs anything other than yes in block capitals, then this bit of the if statement won't run, which means correct will remain as false. Instead, they'll just get a print message saying think hard and try again, and it'll go back round again. And it'll keep going back round until this bit of the if statement changes correct to true. And that's the point at which that will be the last run of the while loop. Now, sometimes we want to break out of a loop mid-flow. So I said that it'll continue doing this whilst it's true. So it'll keep running through the rest of that. If there's more stuff to do in that loop, it'll keep going to the end of that run, even if we've set correct to true in that example. But sometimes we want it to break out immediately. And to do that, we can use a break statement. And I'll give an example here using a for loop, because you can break out of for loops and while loops. Okay. We may want to do that if a certain condition has been met. So imagine we've got this piece of code here. I've got a variable called total that I start off at 0. And then for x in range 10, so a for loop that will do this 10 times, I'm going to take the total and I'm going to add x to the total. So whatever the value of the index is, I want you to add that to the running total. Okay. Now, the way it's going to, I could have written that using the shorthand of total plus equals x would have been the same thing, but just to make it a bit clearer. So it's saying add to total whatever value of the x is, the index at the moment, and make that the new value of total. It'll then print out that value, but then it does this extra check within the for loop and says, well, if the total is now greater than 5, break. And it'll stop and it'll come out of that for loop. So we told this for loop to run 10 times, but it may not run 10 times. And indeed, here it's not going to. So the first time round, the index will be 0. So and the total is 0. So the first time round, it'll say total, which is 0, equals 0 plus 0. So the first value will be 0. That's what it'll print. And the total is not greater than 5. So we're going to carry on. It's going to go back around. Now x is 1. So now it's 0 plus 1 is our total now. Still not greater than 5 though, go back round again. Now our total is 1, so and our index is 2. So this time it'll be 1 plus 2 becomes our new total of 3. Again, still not greater than 5, so it's going to go back around again. So on our fourth iteration, x will be 3, and the total is 3. So it'll say 3 plus 3, so the total is 6. Now the total is greater than 5. So we had another 6 iterations of this for loop to go, but because we've put in this piece of conditional logic telling it to break, none of that will run. So it'll only run 4 times, this for loop, even though we've given it up to range 10, because we've put in this break statement. Now, we mentioned a little bit about infinite loops as well in the Principles of Programming, and also last week when you were trying out some of the exercises. And we said that sometimes you can accidentally write what's known as an infinite loop, which is a loop that will never end. Okay, and we talked last week a little bit about those of you who are of a certain age will remember possibly in early home computers typing this sort of thing into BASIC and creating your own deliberate infinite loop. And this is an example of an infinite loop in BASIC, where you say do this instruction, and then the second instruction says go back and do the first instruction again. That's an infinite loop. It'll never end. It'll always print hello world, and then go back and print hello world, and then go back and print hello world forever and ever. Okay, and sometimes you want to set up something like that. Very often, though, you've accidentally done something wrong, and you've accidentally got stuck. in an infinite loop. So here are some modern examples of an infinite loop in Python. This says whilst x is greater than or equal to 3, then print x, and then add 1 to x, which means it'll only, if this, assuming this x is already 3, this while loop, or 3 or above, this while loop will run. But then once you're in the while loop, you'll never get out of it, because it'll always run whilst x is greater than or equal to 3, and we're adding 1 each time, so it's gonna get higher and higher. So it'll always be greater than or equal to 3. That loop will never end. Similarly, this is an example. You tend to use this kind of statement when you want to create a deliberate while loop, and you'll see examples of that later in the course. While true basically means whilst true is true. It's a shorthand for saying this is an infinite loop. It's a Boolean value of true. It basically just says keep doing this forever. And that's an example where you'd want to create a deliberate infinite loop, for example. Now, we mentioned last week, if you do find yourself getting stuck in one of these infinite loops, and you will at some point, I can guarantee it, you can interrupt the kernel, and you had a practice doing that last week by clicking the interrupt button, and you have to often give it a minute. Sometimes it's not instant, depending on what it's doing in the background. Also, worth noting, if it's currently expecting a user input, and remember that on VS Code that appears at the top, and sometimes you don't notice it, you have to, even if you click interrupt, it will still wait for the user to input before it interrupts. So you'd have to type something in or hit enter. And that would then complete the user input. So it will run to the end of the current instruction. And of course, the current instruction, if it's waiting for user input, is to get the user input. Okay, so I think we're a little bit overrun, but this will basically take us through to lunch. So we'll try and make up some time this afternoon. So having now talked about loops, I want you in your groups to have a practice at using them. So you're going to have 25 minutes to do this. This will take you to 12:30, at which point we'll then break for lunch for an hour until 1:30. And then we'll carry on with the next bit of the lecture. I mean, if you want to stretch your legs, that's fine, but you're going to be breaking at 25 minutes anyway. But obviously, if you do need to take a break, please do so. You're going to work through in your groups Python Notebook 1E_3. Again, read through the instructions really carefully and put your code in the blank cell underneath the description. Make sure you've got somebody sharing their screen, and try and alternate that so different people get a chance to do that. If you finish early, either write see what else you can write, or go off for a nice longer lunch. That's entirely up to you. Either is fine. So we won't. I'll close the breakout rooms when we come back from lunch, so feel free to stay in your breakout rooms for as long as you like. We won't return here into the main room until 1:30 after lunch. So the one you'll need, again being very careful that I don't bring up the solution, is this one here. So you've got 3 tasks this time. The first one, you have to write some code that asks the user to input a number, and the machine will then print out the times table for that number. The second one, you have to ask the user for a number to start from. It'll print a countdown, and at which point, once it reaches the end of the countdown, it will print the message "Thunderbirds are go." And then the third task, which again a little bit harder, so make sure that you work through at least the third task as the group. As a whole group, but if you're getting stuck on the others, make sure that you are working together for that as well. But this piece of code, I've given you the start of the code. Okay, so you need to add to this code cell. The start of the code is going to import something known as the random library. You'll learn about that later. And then there's an example piece of code here which shows how you can use the random library to generate a random integer between 1 and 10 inclusive. Okay, so that little sample piece of code there, you'll need the import statement. You don't need this, but you can leave it in. But it will this will show you. So you probably want to run this line of code first. Add to that block of code to then undertake this series of instructions here. That for those of you that remember the film Short Circuit, will bring a smile to your face. Okay, so have a go at those 3 tasks. Sammy, are there any pressing questions?
No, nothing pressing in the chat.
Excellent. Cool. Okay, hopefully everything's making sense then so far. So I'll open up the breakout rooms now, go to 12:30, and then take an hour for lunch, and then I'll see you again at 1:30. And Sammy and I will be floating around in the breakout rooms if you need us. Great. I'll open them now. Hi everyone. Oh, I've shrunk. There goes. Welcome back. I hope you managed to take a nice break over lunch. It was good to see that you're getting on with the exercise before lunch. So hopefully that was okay. I've just realised I completely forgot to put the solution in. I will do that in the class tannoy now. Number 3, wasn't it? There we go. That one's up there now. If you want to have a look at that. Just so we're about 25 minutes behind. What I'm going to do, I'm going to ditch the next exercise. But when we get to it, I'll just flag it up because I would advise you have a look at it, probably in your groups because it would have been a group exercise, and see if you can tackle it together. So have a chat on Slack or maybe even arrange a call if you want to look at it. We'll give you a bit of practice on lists and dictionaries. It was a bit of a faffy exercise, and a little bit abstract. And you're going to have practice on lists and dictionaries with the other 2 exercises, group exercises you're going to be doing this afternoon, which I will bring everything you've been learning so far together. I'd rather give you the time on those because I think you'll find they will make you feel more comfortable. On that note as well, I just want to shout out in particular to TIA, sat in with TIA just before lunch. And I saw a really nice use of the peer support groups. I just wanted to flag up, and apologies, it may well be that other groups were doing this as well, but I thought with TIA, so if you are doing this, I commend you, and those who aren't, I'd strongly suggest doing it. So I appreciate, I think some people may be getting this a little quicker, others will be struggling a little bit more. That's completely normal, and what we always see with HSMA. I would say don't beat yourself up if you find that you're struggling with this at this stage. Please don't worry, it is going to take some time to bed in. But what was really nice to see in TIA was that actually they took somebody who was struggling and got them to be the person sharing the screen. And this has a massive advantage because it means that the person who's struggling, everybody can then chip in. And those who are also struggling and perhaps maybe struggling a little more quietly can then follow along with somebody who's sort of nearer where they are on that particular spectrum at the time. So I would strongly advise you, if you are struggling a little bit, please don't be afraid to shout. I would advise that you say that to your group in the next exercise or whatever, and volunteer to share your screen, and then people could help you, and you can work together as a group. It's absolutely the right thing to do. It seems a bit counterintuitive, but absolutely, people that are struggling, take that step, volunteer to share your screen. It'll make such a difference because you'll feel a lot more comfortable having other people talking you through. And I can guarantee there will be other people in your group who feel the same way. So you won't be alone. And I'd strongly encourage you to do that. So well done to TIA and anybody else that's doing that. That's exactly how we want to see the peer support groups working. So, but please don't struggle in silence. If there are people struggling, please do shout. There's nothing worse than sitting there feeling lost and feeling as though you're getting even further behind. Sorry, I've just seen in the chat. Have I posted the wrong solution? No, I think that's the right one, isn't it? Let me just double check. No, it is. You're right. Sorry, it is the wrong one. Oh, hang on a minute. Did I post the wrong one before? No, that is the right one. Yeah, that is the right solution. So it should have been exercise 3 that you were doing before lunch. Exercise 4 is the one we're going to skip, but I'll come back to that when we get on to it. Okay, right. Let me share my screen. So we're going to have a slightly longer lecture bit now, but most of the afternoon you're going to be working on some group exercises, some big exercises that will hopefully help to tie all this together a little bit. Because I appreciate at the moment it's a bit abstract, and that's partly because we're teaching you bits of Python at a time. When you come on to put all this together to build a discrete event simulation or build a machine learning model or whatever it will be, things will start to make a bit more sense as well. But at the moment it is a little bit abstract. But some of the exercises we've got for you this afternoon will hopefully make this a bit more real and give you a chance to try out all the various things that we are teaching you so far. So, right, let me share my screen. Oh, sorry, I've lost the button. There it is. Okay, and then we want this one. Right, so let's now talk about lists. So I touched on lists earlier, and I mentioned that lists in particular are particularly useful for the kind of things that you'll be doing. You'll be using lists a lot, and dictionaries to an extent as well, which we'll also talk about. So let's just remind ourselves that lists are structures that allow us to store multiple values, multiple items of ordered data. The order matters in a list, to which we can refer later. And you'll find all sorts of uses for lists as you go through. Let me just talk about some of the basic notation for this. So if you want to create a new list, we can create a new list that's either empty and then add things to it, or we can create a list that's got things in it at the start and then we can add to it and remove stuff if we wanted to. If you want to just create a new blank list, which very often can be useful if you want to create a new empty list, and then very often you'll go through some sort of loop to then add things in. Then the way we do that is we give it the name of the list, the assignment operator, the equals, and then we open and close square brackets. Square brackets are for lists in Python. So that creates a new list called myEmptyList, but it doesn't have anything in it at the moment. So it's not a particularly interesting list at this stage. If we wanted to create a new list that already had some starting elements within it, then we can do that in exactly the same way. It's just rather than just open and close the square brackets, we can say what those elements are, and we separate each element in a list with a comma. And if they're numbers, then we write down the numbers. If they're strings, we need to put quotation marks around, either single or double, whatever you prefer. If they're booleans, we have to put capital T on the true and a capital F on the false, and no quotation marks. But you can store all sorts of things, as I say, within a list. Now, if we want to add an item to a list, we can use something known as the append function. Now, this uses let me just say this first. So the append function, as you've seen so far, we open our brackets and we put in any inputs, and the input to an append function is the thing that you want to add to the list. So if I put append 2 here, that would add the number 2 to the end of the list. Okay, and it'll always add it to the end by default. Now, this thing here is the first time, and I checked in my slides, this is the first time you have thus far encountered something known as dot notation. You are going to see this all of the time moving forward, and it can trip people up a little bit trying to understand what this says. So far, you've seen functions like this, where we just say print, and then open brackets, and then any inputs we need to put in. That's an example of calling a function. This works, print works, because print is an inbuilt core function in Python. Okay, so when you install Python, print comes with it. Sometimes, though, we need to call a function that is a function not of the core Python, but of something that either lives within core Python or, as we'll see later, is from a totally separate package. And the way we do that is using something known as dot notation. So what this says, you'll see that in this example, we've called the append function, but we've got the name of the list that we've created here, and we've put a full stop, and then we've called the append function. What this says is that I need you to call the append function of a list object. Now, you'll remember when we talked about object-oriented programming and principles of programming, we said that we had this idea that there are classes and then there are objects, which are instances of those classes. This is basically what's happening here. And you'll see when we get on to the object-oriented programming in Python in a couple of weeks, you'll see more examples of this. But you're going to run into it before we get to that stage. What this is, when you've created a list here, there is a list class within Python which defines what a list is. And what we've done here is essentially created an instance of a list. And we've got this nice little shorthand that we can use the square brackets because it's an inbuilt Python thing that allows us to instantiate one of those things a little more easily. But that's what we're doing, we're creating an instance of the list class. So now we have a list object called myList. By using the dot notation, we're saying, give me something within that object. And so that's a way, remember in object-oriented programming we talked about objects have things that they carry with them, information, that's the attributes, and things that they can do, which are the methods, which are, remember, just another name for functions. So what we're doing here is we're accessing the append method of the list class. And we're doing that on our particular instance of the list class, myList. So we've created a type of list, we've called it myList, and on that list, I want to use, because a list is an object, I want to use the append method of my list object. And this method will allow us to add an item to the list. So when you see the dot here, it basically means use this, the thing after the dot, that belongs to the thing before the dot. That's basically what dot notation is. Okay, and I flag this up now because you're going to start seeing this all the time, and you might be thinking, well, hang on, I've called a print function down here. I didn't have any dots in it. Why have I suddenly got to put dots? Some things will have dots in them, some won't. It's because there are some things that are methods of sort of core Python functions, and other things which are methods of either core Python classes or external things that you've brought in. So that's what that says. And actually, as you'll see later in the course, you can have subsequent dots, so you could access. Let's say you might have a list which then contains also another object as one of those lists, and then you might use a dot notation to get to something within that. But every time you say dot, it's kind of like going down a level into that thing and accessing something about that object. In this case, a method. So myList.append open brackets 2 will add the number 2 to the end of my list. So exactly, it's much simpler. It's as simple as that. But I just wanted to flag that up, just so that people, if you're new to Python, you probably won't know why there's a dot there. That's why it is, and why you're going to start seeing it a lot. Now I said that lists are ordered. The order matters in a list, and that means that we can refer to specific elements within a list according to their location, and we do that by specifying their index. Okay, because they're all the order matters, then we can say, well, what's the third element? And that will always be the same. So to refer to an element within a list by providing its index, we use the following notation. We give the name of our list, and then we open our square brackets immediately and put in a number that represents the index. Now here I've put in X, because it could be that your number is stored within a variable value. But essentially, whatever goes in there needs to resolve to an integer, and it must be an integer. You can't have the 1.7th element of a list. It has to be a whole number. Now, as I flagged up earlier, Python, like many programming languages, usually starts counting from 0, and this is the first point at which it might trip you up. Because it's all well and good in a for loop, and you can probably get your heads around that. But it also does that in terms of the indices for a list. Okay, which means the first element has an index of 0. The second element has an index of 1. Third element has an index of 2, etc. And this can catch you out, particularly if you're asking for something in the middle that you might forget, particularly if you're new to this, that actually putting a 3 in square brackets here will not give you the third element, it'll give you the fourth element, okay, because it'll start from 0. So 3 is actually the fourth element in the list. So in this example here, if I said my list, open brackets, square brackets, and then put 3 in there, and hit enter, that would then give me back the value hello, which as I say is the fourth element in the list. So be wary of that. It will trip you up. You will get used to it the more you code. And then you'll find that one of the constructs in Python that doesn't start counting for 0, and you'll curse it. But most things do. Most things start from 0. You can also, as well, use negative indexing if you want to refer to an item based on its position from the end of the list. Now, you probably won't use this very much, and usually when you do, it's to grab the last element of the list, or the next to last. You usually don't use it for much else than that, and you probably won't use it too much anyway. But you can do it, and we just use negative indexing for that. But of course, because 0 is reserved for the first element, that means if you want the last element, that's -1. So the first element from the back is actually a 1. It's just a negative one, just to further sort of confuse things. I mean, it has to work that way, but there we are. So -1 will give you the last element of the list, -2 the second to last, -3 the third to last, etc. So you might use that. You'll probably use, mostly you'll probably just put in a -1 there to grab the last element of a list. If you want to, and this is a bit more useful, and you use this a lot more, you can actually refer to more than one element in a list at a time. And to do that, we use something called a slice. And it's known as slice notation in Python, and this is what it means. We basically use a colon, and we can specify essentially a range of indices, and it will grab that as a slice. So imagine you've got your list like a sort of long birthday cake, and you cut a slice out, and this tells it where to cut those slices to take that slice of the list, and that's the bit you're interested in. And as you can probably imagine, that's you use that quite a lot when you need to grab a certain part of a list. Now, when you give the slice notation, the first element, the first index is counted, the second index is not. So just like when you specify a range, as you did in the for loops, it goes from and including the bottom number, up to but not including the top number. So here, my list with a slice between indices 1 to 3 will actually return the value of 4, which is at index 1, and the value of 7, which is at index 2. It won't return hello, which is at index value 3. So it's up to but not including. And that, again, holds true for many Python constructs, but again, not all. In fact, you'll see some on this course where that doesn't apply, just to further confuse you. But generally speaking, they are the exceptions rather than the rule. For most Python things, it's up to but not including. So that's how we could take out a slice, specifying both the start and the end indices. We can also do that by not specifying a start index. So this here, where we just put :2, and there's no number before the colon, means give me everything up to, but not including, index number 2. So in that case, it'll give me the first two elements. Those are index 0 and 1, so 3 and 4. Similarly, we can do the other way around as well. So my list with 3 colon and nothing after the colon would say, give me everything from 3 onwards until the end of the list. In this case, that's just 2 elements, so it will return hello and 2. But if there was another 100, it would give us the other 100 as well. And it returns these things, as you can see. A slice is returned as a list. So it's a way of getting a sublist out, okay, because it's more than one element. If you just ask for a specific element, like here, you get the raw value. But if you ask for a slice, you'll get it back as a list. And sometimes you'll then want to store that sublist in a new list, and call that something else. We can also find the length of a list, which comes in really handy for a lot of things as well. The length of a list is basically just the number of elements that it contains, and we use the len function to do that. But again, len is a core inbuilt function, so there's no dot notation here. So again, that might confuse you. Whereas with the the append, we had to do that as a method of the list object. Len is not. So therefore we just say len, open brackets, and then give the name of the thing we want to find the length of. And len will find the length of any iterable object, and a list is an example of an iterable object. So if we put in len my list, we've got 5 elements in our list, so it'll give us back the value 5. As well as adding items to a list, we can also remove items from a list as well. The remove method is a method of the list object, so we do see that dot notation again. So we give the name of our list, and then we call dot remove, and we then specify the element that we want to remove using the value. So it's the actual value of the item we want to remove if we use the dot remove method. So in this case, if I put that line of code there, that will remove hello from my list. Sometimes though, you want to remove it not based on the value, but based on its index. And to do that, you use the .pop method, so the pop method of a list object. And pop works in the same way. It's just you give the index. So pop and then providing a value of 0 will remove the first element from the list. With pop as well, if you just call the pop method and you don't specify any index, it'll just remove the last element from the list. And that's actually really useful. You'll probably use that quite a lot. If you just need to remove the last thing that was added, you just call .pop, and that pops it off the end. Love the name of pop. It's a great name for the method. Yeah, okay. So we can also do something known as checking existence, which basically checks to see whether something is in a list or not. And that again can be really useful to see whether something's already there. And usually that's then followed up by, if it's not already there, add it. And we can do that using the in keyword. So here we've got a simple piece of conditional logic, much as you've seen before, using an if statement. But rather than some of the comparison operators we looked at earlier, we're doing an existence check. So we say here, if to, so the value I'm looking for, in, and then the name of my list. So if to in my list says, if the value 2 is in my list, then do this. So it'll only resolve to true if 2 is in there. If 2 is not in there, this line of code won't run. So it's don't fall into the habit. So I've seen people, and quite understandably, type the word is before in, because that's what you're thinking in your head. There's no is, it is just in. You get used to it after a while. So if 2 in my list, then print already there. And you can also check the opposite. You can check to see if something is not in the list. And to do that, we just do exactly the same, but we add the word not in front of in. So if 2 not in my list, then that will resolve to true if 2 isn't there. Okay, so you can do it either way around. Now, if we want to copy a list, you might be tempted to do something like this. So imagine we've got my list equals, and then we set up our list here, and then I say, oh, well, I want to take a copy of it because I want to do work with these 2 lists. If I write this line of code here, copy of my list, I'll use my assignment operator, I'll give it the value of the list. That seems in line with everything I've talked about so far. The assignment operator says, let the value here become be sort of put into this. So the value, this is my value here, put it into that list. That should work, but it won't. Does anybody know what will happen?
Pass the pointer.
Indeed it will. So what it's actually doing is not creating a nice copy of the list. What it's doing is it passes what's known as the pointer to the list. That is effectively the bit in memory that tells Python where to look for this variable. And that's how this will work. So what you'll end up with is just another reference to the same list. So you've just got now 2 names that you can call the list. But any changes you make using either of those names to that list, you're changing the same list. There is still only one list, just 2 different references to it. Now, that's probably, in 99% of cases, not what you want to do. I would argue that I've seen very few examples where that's particularly useful, certainly for this kind of thing you'll be doing. What you're usually trying to do is to create a second copy of the list that you can work with separately. To say, okay, I want to take a copy of this list and I want to work with it over here. You see examples of it in machine learning where you'll take a copy, well, we usually do it through NumPy and stuff, but the principles are saying you take a copy of something so that you can leave the raw data there, but now we're going to manipulate this in a certain way, and now I'll take a copy of that and I'll remove all the references to these patients because I just want to look at this. That you'll use much more. And so if you're doing that with a list, instead we have to use the copy method of a list object. So if this is our list, my list, if we want to set a genuine copy of that list that is a separate list in itself, then again we use the copy method of a list object. So we say the name of the list dot copy. We don't need to pass in any input. That would just create a copy of the list. So now we've got two lists, one called my list and one called copy of my list. Okay. Bad. I mean, don't call them that. This is for teaching purposes. That's a very bad name to call something. You should indicate why it's what you're going to do with it, what use it's going to have. But naming things will get clearer as you start to code more. You're always trying to kind of explain what it is in clear and concise terms. Right, now I'm going to teach you about the coolest feature of lists in Python. And this is just an example of why we love Python, because Python has this beautiful thing called list comprehension. Now, very often you don't learn about this kind of thing until a little bit later in a Python course. It is too beautiful to ignore, so it's a little bit more complicated, but I think there's a lot of value in learning this early. Because you will find them so nice. Now, they don't give you any functionality that you can't do without them. They are just a really elegant shortcut, and computationally they are much more efficient if you're particularly working with larger structures. Okay, so what a list comprehension is it allows you to create a list that is based off another list and in some way, and it does so using just one line of code, and in a very beautiful way. So let's think about an example, because that sounds a bit abstract. Let's imagine we've got a list of numbers here. I've called list A, just contains the numbers 1, 2, 3, 4, and 5. Let's imagine I think, okay, I need a second list now, which is all the numbers of the first list but doubled. That's what I want. Now, one way you could do that using everything I've shown you so far, you could write that. You could use a for loop. You could say, okay, well, for each number in list A, then append to list B that number multiplied by 2. Okay, so I've taught you enough to be able to, you could write that, and that would be fine. That's valid Python syntax, but it's not very efficient to do that computationally. It wouldn't matter for something like this. But if you were doing something a bit more complicated, you can start to notice it's not quite as computationally efficient. So a list comprehension, we've got 3 lines of code here. Ignore list A, because that's set up. We've got 3 lines of code here to create list B. We've got the create an empty list, and then the declaration of the for loop, and then basically to append that the number doubled. And some people may even put a 4th line where they would double the number first and then append that number. A list comprehension will do all of those 3 lines in 1 line of code. And this will do exactly the same as above. Okay, so what this is saying, and it's easier often to read these things from the middle, is it says for every number in list A, give me back that number doubled. So give me number times 2 for each number in list A. There you go, done. Put some square brackets around it, that's a list comprehension. That will very efficiently create a list B with 2, 4, 6, 8, 10. And it'll give you exactly the same as up here, but much more efficiently. And as I say, it tends to, you may find it varies, but I tend to find them easier, and I tend to recommend reading them from the 4-bit, because you can then read the bit on the left last. So for each number in list A, give me number times 2. Okay. Now, there's all sorts of other things that we can do in a list comprehension as well. We can also add in conditional logic. So that allows us to create a list that contains all the elements in another list that meet a certain criterion. So imagine we've got list A here, which is just the numbers 1 to 10. Let's say that we only want to. I was about to give you the answer. So no, I will give the answer. So let's imagine we only wanted even numbers from our list. Okay. What we could write is this line of code here. And this would create, using a list comprehension, a second list that only contains the numbers 2, 4, 6, 8, and 10. Because what it's doing here, again, start reading from the 4-bit, says for every number in list A, if the number modulus 2 is 0, in other words, if it's equally divisible by 2, which means it's an even number, then give me that number. Okay? For each number in list A, if the number modulus 2 is 0, give me that number. Otherwise, it will ignore it. So that will create a second list that just contains even numbers. One line of code. Beautiful. It is a thing of beauty. Right, we've already had one, so we can't have another one. So those are lists, and those are list comprehensions, and I urge you to push yourself to try out list comprehensions as much as you can, because they are wonderful, and they are a much more efficient way of doing things, and they're just elegant, and they're much easier to read in Python code. I'm now going to talk a little bit about dictionaries. So dictionaries are also a way in which we can store multiple values. Unlike a list, remember, the order matters in a list. In a dictionary, the order doesn't matter, because instead we have these key value pairs. So the order doesn't matter because to get to any value, we give it the lookup. So it doesn't matter where it is, we just find the lookup. And it works a little bit like a dictionary. You look up, if you want to know the definition of a word, you would look up that word. And it doesn't matter if you're looking up the word modelling. It doesn't matter if it's on page 27 or 2027. It doesn't matter for you. You just need to find the word modelling. So we have these key value pairs, and basically the key is the thing that you will use to look up the corresponding value. And we create a dictionary by using curly brackets instead of the square brackets we'd use for a list. Now, I haven't shown you an example here, but just as with a list, you can create an empty dictionary as well. And to do that, you just open and close some curly brackets. Same as for a list, you'd open and close some square brackets. But here I've created an example dictionary that's already got some entries in it. So I've called it My Patient Dictionary. And each key value pair is separated by a comma. And to avoid going over my 80-character line, I can hit enter after each entry. That's quite a nice way to represent dictionaries in your code, actually, anyway. That makes them much easier to read. And I've got here the value that comes before the first part of each pair, before the colon, is the lookup. That's what the name of the thing is, a bit like a kind of variable name that you're giving to the value. So it describes the associated value. So here I've got patient ID, and then a colon, and then after the colon, the value. So patient ID is this. Name is Bob Smith. Year of birth is 1961. Readmission is the Boolean value true. Okay, so you can see how these will be very useful for a lot of things that you do. So to refer to a particular value in the dictionary, because they're unordered, we have to give the key. The value, the name of the thing we're looking up. So and we do that using square bracket notation. So we give the name of the dictionary, and then immediately open some square brackets, and then in inverted commas we put the name, because it's a string. We give the name of the lookup key, which in this case is name in this example. And so if I do that on my dictionary, it'll return Bob Smith. Remember, that's my dictionary here. So the corresponding value for the lookup key name is Bob Smith. I can also use that square bracket notation in order to overwrite values. So if I just put that without any assignment, it'll return whatever value it looks up. But I can use that to overwrite things as well. So if I were to then put my patient dictionary name equals Dan Chalk, that will overwrite the value associated with the key name with the string Dan Chalk. We can also create in exactly the same way, and this is one of the reasons I like dictionaries, because the way in which you add things is very consistent with everything else. We add a new key value pair for if one doesn't exist in exactly the same way. So if we've got patient ID, name, year of birth, and readmission as our 4 keys. Let's say we wanted to add a 5th key called month of birth. Well, to do that, we just give the name of the dictionary, and then in square brackets we put down the name of the key, and if that key doesn't exist, it'll create it. And again, we provide the value that goes alongside that key. Now that won't work if you don't put an assignment there. If you give the key that doesn't exist and you ask it to return it, it's got nothing to return, obviously, because it doesn't exist. But if you do that as an assignment operation, then it'll create a new dictionary entry with that as the key and that as the lookup value. We can also delete entries that we don't need as well. To do that, we use the del command. So we say del. Now, it's actually a keyword within Python, which means you can't. So there are certain reserved words within Python, with any programming language, that you can't call things like variables because they're used for other words. So you couldn't, for example, call a function print because there's already a function called print. If you do, you will overwrite the print function. Though it's only temporary, but I've watched people do it. You can overwrite inbuilt functions by defining your own one, so be careful with that. And the same for variable names. If you, it will warn you that it's an inbuilt keyword. So you can't call a variable del, for example. It's certainly not as it's indicated there. So if we want to delete an entry, we use the del keyword space and then the name of the dictionary, and then we can provide in the square brackets the particular key that we want to delete. Now, you may have sussed already that the reason we're using square brackets here is because actually we're passing in a list. That's what we're doing. Now, in most cases, it's a list of length 1, but you can delete multiple entries at a time by just simply specifying multiple entries. So that's a thing you can do as well. So that will delete readmission. So if I were to go through all those steps, we'd end up with this new dictionary that has the same patient ID, but it's got my name, it's got the same year of birth, and it's got a month of birth now, which it didn't have before, but it hasn't any longer got the readmission thing. Okay, so this is where you would have done the exercise that I'm going to skip over. I would strongly advise you in your own time to have a look at this exercise, and I strongly advise you to work together as a group, even if that's asynchronously, where you're comparing notes by posting in your peer support group channel. If you want to do it synchronously, great, and you can arrange a little get together to go over this. You'd have had half an hour to do it. Just to give you an idea of how long it takes. It's a single exercise that you do, but it's just a little bit fiddly. But I would advise you have a look at this. I will still post out the solution tomorrow for it, so you can still have the solution. But I would advise you have a go at this first before you look at that, because it'll give you a little bit of practice in using lists and dictionaries. But the reason I'm skipping over it is because I want to get to the other stuff, where you will also get to practice this stuff anyway, along with everything else you've learned today. But I would have a go at this because it'll go into a bit more detail about some of the things that I've just covered there. But it is a little bit more fiddly. Unless you're very confident, I wouldn't recommend doing this exercise entirely on your own because it's just a little bit more faffy. Sammy, it might be a good point just to say, are there any sort of questions on lists or dictionaries that are cropped up?
So we've had a few good questions come up, but we've had some, I've been trying to keep up with them. So we had one question about going all the way back to the remove method. Would that work if there was more than one instance of the item in the list? And the answer to that is it would remove the first instance. So if we had hello twice in the list, it would just remove the first instance. We also had a question about how can lists include things like other lists? So you have a list within a list, and then actually how would you get to an item within that list? And the answer again is yes, you can have a list within a list. And yeah, there's just you use sort of multiple layers of square brackets to actually get further and further through your list, your list of lists. So I'll post a little bit of example code for that in the Slack chat as well a little bit later. And the other one that is just going on, we had some good discussions as well about examples, real world examples of where you'd use lists perhaps in day-to-day coding. So there's some nice discussions in there if people want to take a look in the Zoom chat on that one. Can you append an item to a specific place in the list is one that's just come up. And yeah, I'll let you answer that in a sec.
Oh no, yes, I was just going to say. So you can, if you wanted to do that, you can add. You'd have to. You can overwrite. No, oh, hang on. So because that would involve shuffling everything back, wouldn't it? I don't. Is there a shortcut for that? Do you know?
I can't think of one off the top of my head. I'll go and have a look because I can't immediately. I think I'm the same at the moment. I can think how you could, as you say, overwrite a particular element, but not just shift them all back.
No, I think you'd have to.
Oh, someone's just posted that there might be a dot insert method. So that would.
Do Google stuff like this as well. I mean, anything you're not sure of, because as I say, we're not covering everything. I don't pretend to know about all of the methods of lists. I have to say, I don't think you'll probably ever need something like that for what you're doing, but I've certainly not. But you may well, and there will be stuff that you'll be using all the time that we won't teach you. So yeah, do have a look at Stack Overflow or is your friend, particularly when you're coding, but just googling this stuff actually before. Just also for sort of Sammy carries on, a lot of these things where you've got a couple of the questions around can you do this, best way to do that, just try it, see what happens, type in the code, see what happens. It's the best way. That if I often have questions like that, thinking I wonder if you can do this, try it out in your code. That's why you've got the IPython console is a fantastic feature of Python. It allows you just run one instruction at a time, and live, and just try things out. So sorry, Sammy, I think you had other questions.
No, that's all good, and I completely agree. I was going to say that another way I like to do that is having a IPython notebook is a lovely way to just be sort of running a code cell, trying something else, run it again, see what changes, see how your output changes. Someone's just posted, so Lewis has just posted a nice little code snippet showing that there is an insert, and you put the sorry, I've just clicked and it's just disappeared for me. There we go. So dot insert, open your brackets, number 2. So first you put your index where you want the list, where you want the new item to go, and then the second argument is the what you actually want to insert. So there's great little example there. Thank you very much, Lewis. And the final one is, can a dictionary only store one set of values at a time? So if we go back to the dictionary example, for instance, could it store info of multiple patients for the same set of key values?
Oh, so you can have something. Again, this ties into the point here. The value itself can be a list, and very often that will happen where you'll have lookup, and that lookup value might be, or the lookup key might be patient IDs, and the associated value is a list of patient IDs. You'll see examples of that in the course where your lookup value is in fact a list. You can even have another dictionary if you wanted to go. I wouldn't do that. There will also become a point at which you're nesting things within things, and it becomes you don't tend to want to use these small, simple structures. And it goes back to what I was just about to say about the. So somebody mentioned about the having effectively a two-dimensional list. Can you have a list within a list? Yes, you can. How would you refer to the elements? Well, you could have. It is the square. You just say the square bracket to get to the element of the. If your list. Let me just go back to the list. That'll make more sense. So imagine the word hello wasn't there. Imagine that was a list itself. Okay, so that's element 3. Because it's the 4th element, so it's index 3. So we'd say my list square bracket 3 would get you the list, and then if you wanted an item within that list, you just immediately open another square bracket because you're now dealing with a list within the list. and to give the index there. If you're going down to that level, for the sort of things you will be doing, you are likely going to be, in reality, using things like NumPy and pandas. So next week, we will talk about NumPy and pandas. NumPy deals with multi-dimensional arrays. That's effectively what it is. It's a multi-dimensional array. Just to blow your minds for a minute, when you get into machine learning, you're going to be not worrying about lists within lists. You'll effectively be worrying about lists within lists within lists within lists. You'll be dealing with things that are 100-dimensional, that you can't even conceive. That's why we teach you things like NumPy, because it gets lists are not very efficient. They're useful, but they're not computationally efficient. And so we have this package called NumPy, and we'll talk more about it last week and show you why it's so much better. But it will allow you, where you're doing much more complex things in like machine learning, where you can have 100-dimensional arrays, that's where they come in really handy. So yeah, that will. So in reality, with lists, you may well end up with like 2D arrays, maybe 3D. I wouldn't go beyond that though. Generally, a list within a list is enough. Beyond that, you're probably looking at NumPy realistically for the stuff you'll be doing. Okay, cool. Thank you all of them. And Lewis, if you want to pop in the chat what your peer support group is, you can have 5 points for that. I think that deserves a little commendation for going off and looking that up. How nice. There we go. I feel whimsical. Everybody's wishing they'd done it now. Okay, so that's the exercise. That you would have done. So I would advise you go and have a look at that. I'm just going to talk for a tiny bit longer, and then we'll take a break, and you'll go into the bulk of this afternoon, which are going to be hopefully some quite fun exercises. And there's lots of PSG points up for grabs this afternoon as well. So I'm just talk briefly about importing packages, because you're going to need it for the next bit. So we mentioned a little bit about, well, in fact, quite a lot about packages last week. We said that one of the great benefits of Python is that we can import pieces of code that other people have written, and we can install packages. And we looked at how we can pip install things. We can install them from environments, import an environment, and that will install various packages we need. But those things just install it onto our computer. If we need to bring it into our code, then we need to use what's known as an import statement. And an import says that thing that's installed, give me that package into this piece of code. So you may well install, and you will on this course, you will install the SymPy package, which is for discrete event simulation. You're only going to be using the SymPy package though when you're doing discrete event simulation. You'll have no other use for it outside of that. You're not going to do geographic modeling and import SymPy. That makes no sense. So there's a difference between installing a package that you have available as part of your Python toolbox on your computer, and then importing it to say, I need to use this package or part of this package within this piece of code that I'm writing. And that's what we mean by an import statement. So here are some common examples of things, the ways in which you might see import statements look. So this first entry here says import the package named string. So there's a package called a library called string. You might hear them referred to as libraries, by the way, as well. It's interchangeable. So if you hear me say sometimes libraries, I mean packages. You might hear them referred to as modules as well. There are subtle differences, but they're largely interchangeable. The second way, so that's one of the most common ways you'll see all the time, import and then the name of the package. And these import statements always appear, or they should appear at the top of your code. It's bad practice to just import them as you need them going through. You don't do that. Import statements live at the top of your code. So you import everything. So if you forget something, I think, oh, I need this package. I forgot I need to import that. You go back to the top and you add it as an import statement to the top. That's just good practice. So that's one of the most common ways. You'll also see this sometimes as well. So this second one says, from the matplotlib package, which you're going to learn about in a couple of weeks, from the pyplot bit of matplotlib, so the dot notation, remember, same thing here, that lives within this. Import just the pyplot bit of matplotlib and import it as PLT. Now this is known as an alias. And what this says is, henceforth, rather than typing matplotlib.pyplot every time I need to access something in matplotlib.pyplot, I'll just say plt. And you can do that with any import statement. It's, if I need to get down to you might be importing a particular method. There's only one method you need out of an entire package, and you don't have to write out all the dot notations. I'll refer to it hence as this. There are some packages that have standard aliases that you are supposed to use. Python won't make you, but the coding community will frown upon you heavily if you do not. So never change those things. Matplotlib.pyplot, see why we need an alias, is one such, and you always use the alias plt for that. Pandas and NumPy are also examples where there is a commonly used alias that you are supposed to use, and you'll see more about that next week. So this imports everything, import string, import the entire package called string. This says just import the pyplot bit of matplotlib and import it under this alias, so that henceforth, whenever I say plt, I mean this. And then the third way you'll also see as well is you can say from this package, so from word cloud, import these things, and you can comma separate them. Say, okay, well, I need just one or two things from this package. So rather than import the entire word cloud package, if I only need these two things, I'll just import these two things. If in doubt, the import will work, but there are some very large packages. You don't want to always install everything. Import everything. Things like SymPy you tend to, because you could discrete event simulations, you just tend to use anything within there. But there are certain things, like the math library is very big. You don't tend to import the entire math library just because you need one mathematical function that's in there. Now, the random library within Python is a particularly useful library for our kind of work, because it allows us to generate random numbers. It's got lots of really useful methods that allow us to do that. And that is particularly useful for us because most of the models that you're going to be building, most of the models we're going to show you how to build on this course, with the exception of one example, which isn't based in Python anyway, are going to be what is known as stochastic models. So there are two types of models: stochastic and deterministic. A deterministic model means you plug in the numbers, and every time you run the model, the same results come out. There's no randomness. It'll always give you the same results given the same inputs. But most of the models you will build are stochastic models, and we talked about a couple of weeks ago why we need to build stochastic models, because the kind of systems that we are building, that we are modeling, have randomness in them. We don't model an ED where everyone spends exactly 3 minutes with the nurse and spends exactly 17 minutes with the doctor. It doesn't work like that. There's real world variability, and that real world variability is important in things like a queuing model, because whether the patient spends 17 minutes or 15 minutes can have a knock-on impact in terms of a queue building or not at all. And all those little variabilities can be incredibly important. So you will generally be building stochastic models. And you'll remember we talked about, in order to do that, we use these things called probability distributions, which is basically our way of representing variability within our data. And the way we do that is we say, well, on the y-axis, we have the probability of any value on the x-axis occurring. And we use that essentially to represent various activity times and inter-arrival times in our model. So we can say, well, there's a 50% chance for any patient that comes in, a 50% chance they spend 3 minutes with the doctor. There's a 40% chance they spend 4 minutes with the doctor, etc. And we tend to do that using named distributions. You remember we talked about we tend to use mostly exponential and log normal distributions, and feed in our particular parameter values that then shape that particular distribution. So that's why the random library is going to be useful, but we haven't taught you how to do SymPy or anything like that yet. That's to come in a few weeks. But for now, it is going to be useful for this afternoon as well. So we're going to use the random library. So to import the random library into our code, we can simply say import random, put that at the top of our code. We don't need to pip install random. Random comes with the Anaconda distribution of Python. I can't remember if it comes with core Python or not. I think it does, but if it doesn't, I mean, you're using Anaconda, so it definitely comes with Anaconda, and that basically says, okay, I'm going to in my code, I'm going to need the random library. It's good practice if you find you don't. Sometimes you import something and think, oh, I didn't need that in the end. Get rid of it, delete it. You don't want to be importing things that you don't need. So only import stuff you do. By the way, for most of the stuff you'll be doing moving forward, you will be importing pandas, NumPy, and matplotlib, plus some other stuff. Those are the 3 big packages for data science that you will need for a lot of what you do. So here's some useful methods that you can run with the random library. So random.random, there's our dot notation again. Remember that saying, from the random class, give me the random method. So that random method just gives us a random number between 0 and 1. And it samples that from a uniform distribution. For those who don't know, uniform distribution just basically means every possible value is equally likely. That's all it means. So there's an equal chance of any number between 0 and 1 being picked. That's quite common when you use random.random, because very often you need to randomly generate a number between 0 and 1 to determine some sort of probability or something like that. So random.random is quite useful. You can also, though, generate a random integer, whole number, and you can use random.randint for that, and you specify the number you want to go from and to. And remember, I said you're going to see some examples where it doesn't play by the rules. So up to now, I've said it's from this up to, but not including the top. That doesn't apply for random.randint. That includes the top value. So that does mean, and it give me any number between 1 and 10 inclusive. So 10 can be picked. Just to further confuse you there. It is the exception, though. Generally, stuff like this, it normally doesn't include the top. You can also use random.choice if you want to randomly select an element from a list. So imagine I've got a list here. My list has got Dan, Sammy, and Amy as the entries. If I call random.choice and I pass in the name of the list, it will randomly pick one of the items in that list. And again, that can be really useful as well. Okay, right. So let's hopefully that's made up some time. So we're going to get on to, we've got 2 more exercises to do this afternoon, and these are the big exercises that are going to help pull everything together. So the first thing I want you to do is this exercise, one of my favourite exercises in HSMA, which is, are you smarter than Dan as a 4-year-old? Okay, so you will recall that I told the tale in the second week, and I said that I was teaching you programming based on how I learnt coding using my old Atari 800 XL, using my invitation to programming cassette tape that guided me through the principles of programming, just as I have with you. And one of the programs, my very first proper program beyond, print hello world 20 go to 10, the very first what I would term a proper program was this. And you are now going to write the program that I wrote in BASIC nearly 40 years ago. Okay, so in the program that I wrote when I was 4, the computer would randomly pick a whole number between 1 and 100, and the user basically had 10 chances to guess what the number was. Every time the user guessed, they'd be told either the number was too high, or too low, or correct. If they used up all 10 chances without guessing correctly, they were told you lose, and then they were told what the correct answer was, what the number was, and the game would end. So I have now taught you enough today for you to write this in Python. But I want you to not only write the program that I wrote as my very first program when I was 4, I want you to add some bells and whistles to it that I didn't when I was coding it in Atari Basic. So as well as this that's described here, I want you to add these features to it as well. I want you to add in a score which starts at 1,000 and which reduces by 100 for every unsuccessful guess. And if the user wins, it displays their score. I want you to add in a feature where the user's guesses are stored in a list, and then that list gets printed once the game is over. I want you to add in a feature where the game asks if the player wants to play again after every game ends, and after each game, I want you to get the player's score to be checked against the current high score, and the default is 0. And if the last score is higher than the recorded high score, then this replaces the high score. And if you manage to do all of that and you've got time to spare, then feel free to add in any extra bells and whistles that you want. But you're going to work on this as a group. So make sure you're working on it as a group. So you've got one person sharing their screen, and you're going to tackle this together with one piece of code that you come out with at the end. So I'm going to ask you to take a 10-minute break first, because you've had a long lecture bit there. So we're going to have a 10-minute break now, and then you'll have 40 minutes. So we'll resume at 3:20. Okay. So I will stop sharing now. I'll open up the breakout rooms, break for 10 minutes, and then you'll have 40 minutes, so till 3:20. Hi everyone, welcome back. Managed to get around, I think, most of the rooms there, and saw some really good attempts at trying to solve this particular problem. Well done to everyone. I'm going to post the solution into the class Tannoy now, so you can look on, but it is just a solution. I saw some people doing some nice alternative versions of that as well, where they were using a while loop for the guesses as well. So the way I've done it is using an outer while loop for continuing play, and then an inner for loop with a break if they guess it correctly. But that doesn't mean that's the only solution. And just to re-emphasize, there are multiple ways, as with most coding things. So pretty much everything you're going to be seeing in terms of solutions moving forward are going to be, this is one way to do it. It just happens to be the way I've done it. So don't think there's necessarily a single right answer, and there will be different approaches, and those approaches will change as well as you learn new things on the course too. Okay, so I'm just going to share my screen again, and so we're going to get to the final big task of the day, and we introduced this a couple of years ago, and it was very successful. And I think this is probably, I said the previous exercise is one of my favourites. I think this probably is my favourite, certainly of all the early exercises. Is the HSMA coding competition. Now, there's going to be a few of these over the next few weeks, but basically today you have learnt a lot, and I think it's worth just taking stock for a moment to consider all the things you've learned today. You've learnt how to print to the display, you've learnt about variables and casting variables, getting inputs from the user, writing comments, about mathematical operators, conditional logic, for and while loops, working with lists, list comprehension, dictionaries, about libraries, importing packages, and a few methods of the random library as well. So you've learnt a lot of different stuff, because most of you had zero Python experience this morning. So first of all, you should pat yourselves on the back. That's quite an accomplishment that you've managed to get through all that in one day. So to kind of bring all this together, what you're going to do now is you're going to go back into your groups, and I'm going to give you just under an hour, and you are going to, as a group, each group is going to design and build a computer program that will use some or all of the things that we've covered today. Your program can do absolutely anything you like, and I advise you to be as creative as possible on this as well. I would flag up that for fairness, we would advise people to stick to the things that you've learnt about today. Now, there may be things, little extra features that you want to put in that you've looked up as a group or something like that. That's fine, and Sammy will be looking primarily at a good demonstration of the things we've covered. So if you want to put in extra bells and whistles, that's fine. But don't come back with a fully working machine learning model. We haven't taught you about machine learning. That's great, but you're not gonna win because that's not really the spirit of what we're asking at the moment. So I'm going to give you till 4:20. So you've got 55 minutes. You have to design and build. So first of all, you need to, as a group, have a quick chat about what you think your program should do. Come up with anything you like, and then you need to have a go at coding it as a group. So have one person sharing the screen and all chip into to suggesting how that's going to work. And then each group is just going to have 1 minute at the end to present their code, their program, explain what it does, and Sammy will then judge the top three that she thinks are the best three entries, and the top three will get 15, 10, and 5 PSG points apiece. So all to play for. So be as creative as possible. Bring together the things you've learnt about today. I say you are allowed to bring in stuff that we haven't covered, but just be aware that we're not going to be looking. We'll be dismissing that almost for the purposes of this. So try and your core code should be based around the concepts that we've covered today. Okay, cool. Let's go back into your breakout rooms, and I look forward to seeing what you all come up with. Hi everyone. Okay, so welcome back. I have to say I don't envy Sammy this task of trying to pick the best, because I just went around the rooms and they're all brilliant. They're really, really creative. There's a reason this is one of my favourite tasks, and it was so good to see you all being so creative and so engaged with this stuff. Do not underestimate how important creativity is when you're coding, and one of the reasons we do little tasks like this, and there'll be more of them as we go on, is to get you into that creative mindset, particularly when you're building models as well, and a lot of that is very creative in the way you approach things. So we try to balance out the kind of we need you to do X, Y, and Z, write your code that does X, Y, and Z with stuff like this, which is really what you're going to be, how you'll be working on your projects, coming up with brand new things and creatively thinking about how to approach that stuff. So really, really good to see. It was hilarious watching some of those. There seem to be common themes of Cornwall, bees came up a lot, vintage computing, and Bruce Forsyth. So I think you all captured the spirit of me very well. But Sammy is going to be the one that's going to judge. So we're going to be quite, because we're tight for time. We are going to be strict with this. So we're going to go through each group. You will have only 60 seconds to pitch your code. So once you start sharing your screen and we say go, you'll have 60 seconds, and we will cut you off if you go over. And then Sammy is going to make a judgment in this session as to who the top three are. And I haven't consulted with her. I've got some private notes about some potential additional points that I might award for other things that I've seen going around, but Sammy doesn't know about any of that at the moment. So we will go through the groups. We'll do them in order just to make it quicker. So we're going to start off with Agnes. So does somebody from Agnes want to share their screen? And then you'll have 60 seconds.
Sure. Hang on. Alright, where am I sharing? Sharing. Okay, so ours is inspired by Tamagotchis. I don't know if people remember them. So hang on, I normally not. I haven't practiced this. Go away. Okay, so we've got the thing bar at the top. What do people want to name the dog? Does anyone want to shout out? Otherwise, I'm going to call it Bob. Okay. This is running a bit slower than it was before. Oh, I can't see the bar because of the screen. There we go. Okay, so what would you like to feed Bob? Choose from this list. So we've got beef, corn, chicken, fruit, rice, or biscuits.
Beef.
Okay, so our pet score is now 74. And when we were doing this in the terminal, we had a nice pet health bar appear, but so we can continue feeding Bob different things, and his health might increase or deteriorate. And just to show people how it works in the terminal. Oh no.
10 seconds. I forgot to start the stop. I think I've been
anyway. Well, oh, that's a shame. I shouldn't have tried to do something new for this. I'm trying to stop it, and I can't. So there we go.
I'm going to have to cut you off, but yeah, I think I
Sorry.
saw a glimpse of the health bar down below, which I thought was very cool. So thank you. No, really creative. Really liked that. Right, just to warn you for the rest of the groups, I have got my stopwatch app ready now. So as soon as I say go, you literally do have 60 seconds. So next up, we've got Antic.
Yeah, that's me. I'll just share my screen. Okay, so cool. So we have done a pop quiz. We just picked some questions off the internet. They're not particularly interesting, but we've got 5 questions, 5 answers. Some of the answers are string, some of them are integer, and then we've got this list of question numbers. And then basically it loops through, and you have to answer 3 questions picked at random from the list. If you get one of these 2 questions that's an integer, then your user input has to be converted to an integer. It checks the answer, it tells you if you've got it right or wrong, and gives you points. And then when you've hit the limit, when you've hit 3 questions, it gives you your final score and a percentage. And we've got this bit that gets rid of the question that you've already asked. So I'll just demo. So you just stick your answers in.
Time's up. Sorry.
Oh, sorry. Cheers.
I think we got the gist of that. No, sorry, I did say I'd have to be strict. So, thank you. No, that was really good. I really like the pop because I liked the feature that you can remove the questions. I like that. That's very, very cool. Thank you. Okay, Arm, you're up next.
Hi, that's me. I'll just share my screen. We have created the great Euro penalty shootout simulator in honor of the tournament that starts next month. So we run this in the terminal below. Oh dear. Cool, we get to pick our first team name. So we picked HMSA United versus Python FC. And then we pick a number between 1 and 4, and that compares against a random number generator to say whether you've scored or not. So if I pick 1, I've missed. Or number 2, because Python FC is up, they've also missed. So after 1 round, it's 0-0. So if I just keep going, go through the next one, we're still at no goals. Maybe we didn't get the probabilities quite right. That's for the next iteration. Still, oh, finally we've got a goal. Python FC have scored. Let's keep going. Another goal for HSMA United. Oh, it's neck and neck going into the final round.
Time's up, I'm afraid.
Sudden death. There we go.
Oh, yes, we've got to sudden death. I love the ASCII graphics. Very nice. Very nice touch. Thank you very much. Okay, so next up we've got Denise.
That's me. We've designed a game. I'm saying game, but it may not end well for you, Dan. This is where you guess what your cat wants. It's heavily inspired by your cat. So you have a choice. You could input what you think it needs. You try feed. No, it's unhappy. Try something else. Yeah, cat's happy. But if you were to try something different, yeah, good luck, Dan.
Very good, thank you. I like that. That's less a game, more a simulation of my life, really.
That's what we thought.
Yeah, brilliant. Thank you very much. Fantastic. And well within the time. Well done. Excellent. So, so it was Denise, wasn't it? So Motorola.
Thank you. That's myself. I'll just present on the screen. Is that showing okay?
Yep, that's all cool.
Grand. Thank you. So we did have some quite grand requirements and ideas going into this. We were hoping to build a tic-tac-toe game where you could play against an AI and keep track of scores and tying in all the different kind of functions and bits of learning. We didn't quite get that far, but we do have a tic-tac-toe board of sorts. So we created a board list. We have a random generator to show who's going first. It's hard coded, so the computer goes first at the moment. So kind of in developmental user testing stages, I would say, but essentially by running it, you can see that the computer is selecting one of the numbers across the list in each go. So yeah, it's a bit of a different type of tic-tac-toe game, but one that, as I say, hopefully with more work, we'll be able to release soon.
Excellent. No, thank you. I shall look forward to the Motorola remix of Tic-Tac-Toe. No, very good. Again, very creative, and I liked the ambition. It was really nice to hear in one of the groups as well. Somebody suggested, should we make this a bit of a sort of long-term project that we work on as a team? That's a great thing to do. So I'd love to see all of these really actually worked on in a really nice way to practice your coding skills and work together as a group. So definitely would recommend anything like that. Cool, excellent, thank you. Paula, you're up next.
Yep, hello, that's me. We are the new best game developers in the UK, potentially. We have made it choose your own adventure game. So we're starting. Hello, what's your name? Oh. It might take a bit tough time because we've got some timers in there that slow it down. I didn't realize we only had a minute to present. Anyway, you run into an old lady. She's a witch. She's stealing Sammy. Oh no. What way do you go? Left to the gate or right to the narrow alleyway? Let's go left. You walk through the gate and find yourself in a forest. On the forest floor, you spot a trail of strawberries. Do you want to pick up 2 strawberries? Yes. Oh no, your backpack is full of bees, Cornish pasties, a Nintendo 64, Atari, and a tiny Sammy. Which one do you want to drop? Let's drop Atari. You back through the gate. Walk into the alleyway. In the alleyway is a cat called Dan. All of a sudden, the cat attacks you. Your bag feels lighter. You check your backpack. You're missing the Nintendo 64. No. You find some cream. Do you want to pick it up? Yeah. That's as far as we got. If you want more game, give us some money.
Brilliant. No, thank you. Very, very funny. I did enjoy the references there, and I liked the way you put the timer in actually for this. It gave it a really nice feel as the messages came through. Brilliant. Thank you very much. Okay, so which was that, Paula? So I completely lost. You were Paula, weren't you? So Pokey next.
Can you see that properly?
Yeah, that's come through.
Right. So we made a game. We made Formula B Racing. If we select the B option, it will give us some B stats. So we have our name Sting, and we have some randomized stats in speed, resilience, charisma, and wisdom, and we can enter our B into races. So if I choose the race option, we get commentary on the race. So we start in Padswo, and we get randomly generated events based. So we check the stats of our B, and if the stats are high enough, we can pass the event. If not, we fail the event and we get a time penalty. So we'll go through all of Cornwall with some added time stops to make it more suspenseful. Then we get a final total time, we get a final placing, and we get a motivational quote. But the interesting thing is, if I go back to the B options, our stats have now increased because our stats increase after our success in the race. Now I've got 5 seconds left, so I'm going to show off 2 seconds of the code. There it is. Here's the lovely ASCII art.
Again, thank you. Again, love the ASCII art. Very, very, very cool. Love that idea. Really nice. I love the fact that you've added in that their skills improve after a race as well. And love the puns, which is very HSMA worthy. So well done. Fantastic. I'm loving all these. These are brilliant. Sid, you're up next.
Yeah, so that's me. So yeah, we have also made a lovely little text here that is right in the middle of the button. So we've been dumped. We get a choice. We get to go north, south, east, or west. I think I'm going to go west. But that's a disaster. I've fallen off a cliff, but I'm a resilient now. I've got 2 lives left. So I'm going to head east this time. That sounds like a much better idea. I'm going to learn how to spell as well. Oh, nothing here. Let's see. See if we can find anything. See if I can find any treasure. Randomly positioned treasure makes this difficult. Oh God, no! Now they're falling in the trap door. This is just getting worse. So maybe we don't start by going east. Maybe we don't go all the way to the north map there. So let's try going straight up. Yeah. Head over the board now. See if I can't find anything over here. Another. I fell in a trap door again. I'm not a very good adventurer, is what I'm learning here. If I were better, I might have found some treasure and a key to open the treasure. But unfortunately, I'm not, and I'm just dead.
Well, you lost your last life bang on 1 minute, so you're a good timer, if nothing else. So brilliant. Thank you very much for that. And then we've got TIA. You're muted, by the way, just to let you know.
Thank you very much for that. So, can everyone see that now, and can everyone hear me?
Yep.
Yeah, perfect. So we've got a game for children, which, as with all children's games, is based on pure mental mathematics. So we need to establish what the child's name is. And I'm going to pretend to be 8 for the purposes of this, because it does make it quicker, which is a lot easier when you've not much time. We just then get some simple maths questions. We start with addition. We can then keep playing. We get some subtraction. And yes or no. We get some multiplication. 3 times 9. So I know that's 27. I'm just going to say it's 28 for now, just to see. No, you get some lives lost. And you get a different question if you don't know it. 40, yes. What's 3 divided by 3? We get 1. And then we could potentially loop back around if we want to, but I'm going to call it a day there. And we can see, because I've got the division question right, I earned platinum badge this time with a score of 400.
Brilliant. No, thank you very much. That was really good. I like the little twist you put in there of having different badges, and I see when I went to the rooms that you had different levels of scale of numbers for different ages as well, which I thought was a nice little feature. So
yes, I set it to the easier one to try and get it through in a minute and not make a fool of myself in public.
I was rather hoping you were going to go for the one where you had to do multiplications or something. So excellent, thank you. And then last up, we've got Zylog.
Yeah, that's me. Okay, hang on 1 second. Let me just make sure I share with sound, because we have got an intro for ours, obviously. Yes, hopefully I can find it. Here we go. So we have recreated the classic. Ready to play? There's not too much of that. Yeah, we haven't got much. Oh no, it's not rendered. Oh no. But anyway, basically, long story short, it prompts you for a card. We've got this whole lovely shuffle of the deck. It puts a card, and you've got to choose if you go higher or lower. You get 5 cards right in a row. You win one of these wonderful prizes coded here below. So a copy of Short Circuit, Speedboat, a TV, a trip to Cornwall, free Wimpy's, free blockbuster rental, huge amounts to be won, all just by getting 5 cards in a row. So I'm not quite sure why that's not working today, but yeah, it's all there for you to review at your leisure.
Brilliant, thank you very much. Well, I can vouch that when I stepped into your group, I did see a nice photograph of Bruce Forsyth. So I can vouch it did work at least. Fantastic, thank you. Really, really interesting use of the game. Right, so Sammy has seen 10 very interesting, very diverse, and very creative entries there. I think it would be fair to say. I think all of them are absolutely excellent and really well done. Again, just before Sammy sort of makes the final call, I have to say, bear in mind that just at 9:30 this morning, most of you knew no Python code whatsoever. So the fact you've come out with these 10 fantastic pieces of code and it's now only 4:30, I think is a pretty impressive testament. So if nothing else, you should all pat yourselves on the back for that. But I'm going to hand over to Sammy now. Sammy's going to give her judgment on the entries that have been presented to her.
Yeah, this is really difficult. I'm really struggling to make some decisions here because I think everyone deserves points, which isn't much use to anyone. So, honestly, first, well done. That, as Dan says, you have come up with some really nice ideas, and the creativity really is important. It does make such a difference. Creative use of other people's code, of coding concepts, that will take you so far. I'm going to base my decisions primarily on, good use of concepts that we've taught today. And I will try not to be too biased by wonderful creativity, but in terms of storylines. But so I'm going to give joint bronze to Denise and Paula. I think Denise, I just wanted to highlight that, you've done some really nice stuff with, use of random choices. You've made some really nice use of for loop of, your if statements and your elifs and stuff. So I just wanted to recognize that. And Paula, how could I not? That was a fantastic, lovely list, lovely game. And I really liked how you were using the list as a backpack and popping things in and out of that. In silver, I'm going to pop Sid. I really liked your tracking of your location and your stats. I thought you'd done a really, really kind of creatively done that, coming up with your trap arrays, randomly as well, randomizing where the traps were placed. That was really good to see. And in gold, I'm going to put Pokey with Formula B. So yeah, I thought I really liked how you were tracking your stats over time, and the like. So, and yeah, lots of good use of if and else and looking through just lots of nice concepts. So well done, everyone. I hope that seems fair. And Dan, do you have any additional points to add?
I do, yeah. First of all, just say, yeah, no, I think well-deserved points awarded there. I think I have to say Formula B was a particular favourite of mine. I thought that was fantastic, both in terms of creativity and the features and the coding skills that you showed there. So really, really well done. I did make some separate notes for additional delegations. I was trying to look at not so much the content, but some of the ways in which I've seen people interact and work this afternoon. So I've got some extra points, so 5 points apiece too, and some of you may get additional points here. So Paula, I want to give you 5 points. I thought you were the team that I came in and made the suggestion about doing this as a long-term sort of project, team project. I thought that was such a fantastic idea. So 5 points, well worthy of that. Pokey, again, I came into you and I heard that I could witness one of you had written a little function that had sort of tidied up various little bits, and that you delegated the ASCII art out and somebody pulled that in. That was a really nice collaborative thing that you did there. On a similar note as well, Zilog, a really nice demonstration of collaborative coding. One of you, when I was in there, sort of said, "Oh, I've got this little function that will improve that. I've written that. Do you want me to give you that?" That was really nice. What a fantastic example of collaborative coding there. And then lastly, I'm going to award 5 points to Agnes. Joel earlier put in the coding clip. For anybody who hadn't seen it, there's a nice little tip which I didn't even know around Zoom and how you can zoom in on the code, which is so important. I'm aware that people are struggling sometimes to read some of the code. So well done, Joel. People may have known that, but I didn't. So thank you for sharing that for everyone. Really good. If anybody has tips on how to use things, please don't assume that other people know. Please do share stuff, because it's always really good. So Paula, Pokey, Zilog, and Agnes, you get 5 bonus points each as well. So lots of points there this afternoon. But as Sammy said, we'd have happily awarded lots of points to you all if it weren't completely pointless. But really, really well done. Genuinely fantastic work from all of you. There will be lots more opportunities. There may or may not be another coding club, a coding competition next week. Indeed, there may, and there'll be lots of more exercises like this as we go through the training as well. And it's really good to see you all engaged so well with that. So I'll close off there. Apologies, we have overrun, but hopefully that was worth it for those PSG points. And it was certainly worth it to see all your fantastic entries. Do share your code on your channels. And as I say, if you do want to carry on working on those things, please do. I think that's a fantastic idea to have a little sort of mini project that you're working on to polish up your coding skills that you can add to as you get more accomplished and add new features as you learn about new things as well. So really good first day. Hopefully you all enjoyed today. It was a bit less chaotic than last week, hopefully for you. And next week we'll carry on our Python journeys, where we're going to talk a little bit about functions and about working with files, both of which will be important things that you will do quite a lot in for what you'll be working on. And we're going to spend quite a bit of time on NumPy and pandas as well, two very important libraries for data science coding. Excellent. We'll stop there. The recording should go up tomorrow. I'll put the solutions up as well, and we'll update the leaderboards for you. But until then, see you next week, everyone. Goodbye.